Hello, my friends. How's it going? I hope you're doing well. We are back streaming. Let me actually start the Twitch. All right, hello everybody. We are back. Today is Friday, February 25th, 2025. Hope you're having a wonderful day so far. Today marks the start of week 8 of Harvard CS50X. Let's go ahead and light the candle. Ah, we are finally jumping into week 8, which is going to be on web development using HTML, CSS, and JavaScript. This is going to be a great opportunity for us to really reinforce some previous learning I did in the, what was it? The Odin project. I completed about half the Odin project in my free time about 4 months ago after I completed Harvard CS50P. I did about half the Odin project. I made the recipes website, I styled it, and I think that's as far as I got. I didn't actually enter into the JavaScript portion, so that'll be new for me today completely. I have never actually read or used JavaScript before, so that'll be completely new for me, so bear with me as we try to learn that together, but we're going to be doing it completely live and authentic here on the stream. So thanks so much for joining me, everybody. If you're excited for week 8, give a thumbs up or a like in chat. Let me know what week you're on if you're studying alongside me. Let's go ahead and throw in the Discord and let everybody know that we are going to be doing week 8. Everyone. Watching Harvard CS50X week. Okay, so starting Harvard CS50X week 8. HTML, CSS, and JavaScript. We are watching the first half of lecture 1 of lecture. Join and learn with me. I am super excited to get some web dev exposure. Oh boy, web dev exposure. Is this where we start making day in the life videos as a web developer? At my job? Is this where we start Guys, is this where we start showing all of our perks and benefits as a web developer on TikTok? Let me know. All right. Tim, how's it going? Welcome in. Good evening, Professor. Looking forward to today's lecture. Awesome. Hey, Alex, and welcome back. Let's read Donald Nuth. Who is that? Don't know. I've never heard of him before. I hope you guys are doing well. Let's get into this lecture sooner rather than later, as it's going to be a long one. We're going to watch the first half of it today and the second half of it tomorrow, and we'll dive into the problem set shortly after that, probably into this weekend. But guys, we started this course January 1st, so if you've been procrastinating starting this course, we just started it, a few short weeks ago, and look at us already. We're almost done with the course. We're right on track. It's not anything crazy, just doing, about average a week every week, right? And it's so far taken about 2 months, and we'll be done. 2 months of studying and hard work, dedication, and then we get this knowledge and we can go on from there and make some more projects. So without further ado, guys, I hope you're having a good day. We're going to be jumping into Harvard CS50X 2025 Lecture 8 on HTML, CSS, and JavaScript. Oh, shoot, guys. I got to start my recording. I got to do that intro again. My fault, guys. My fault. You're going to have to bear with me again. All right, we are doing Harvard CS50X 2025 Lecture 8 on HTML, CSS, and JavaScript. This is going to be 2 parts lecture. This is part 1, the first half of the week 8. All right, let's get into this, guys. Keep chatting it up. Let me know what you guys think about the course. Any notes? I'll be chatting it up here with you guys in the chat. I won't be talking throughout the course just to not disrupt the flow and the learning of everybody. I'll be taking my notes on the left side, and I'll just type in the chat and say hello. Hello, Buggy Burrow on Twitch. How you doing? Welcome. Awesome to hear from you. How you doing? Oh shoot, I'm not signed in on Twitch. I've got to log in here. Hold on 1 second, guys. I don't know my... Oh, shoot. Nope. Nope. Hold on, guys. Give me 1 second. I gotta fix something with the Twitch here. Give me 1 second here. It's Twitch. Okay. We've never gotten that. Oh, really? It doesn't let me copy and paste, guys. I gotta type this out. Sorry. No, dang it. Really? Give me 1 second, guys. I appreciate you guys bearing with me. We'll get this started in just a second. Sorry. Did not expect. I gotta sign into this thing. Okay, now hold on 1 second. Thank you for being so patient, everybody. We'll dive into the lecture here in just a second. Just trying to make sure I have everything set up for the Twitch. All right. All right. Hey, Buggy Burrow. Yes, this is the Harvard CS50X course 2025. We got that sorted out, and I was able to send you a chat back on the Twitch live here. I got the chats here. Let me know. Do you guys want me to put the chats on the right side so you guys can watch your chats come up live on the stream as well? Do you guys think that's fun? We're kind of limited on space. I don't have exactly I'm not the pro streamer yet to have like the transparent chat and the alerts and all that stuff. I need to get some, that would be cool. I need to get some alerts and really make this a setup here, guys. But all right, let's get into this lecture. Keep chatting away, and I'll respond to you guys in between the breaks here. Awesome. Let's go get it. How's the audio, guys? Let me know how the audio is. You guys want it louder, lower? It sounds like it might be loud here. Let me turn it down slightly. Let me know how the audio is.
All right, this is CS50, and this week we begin to introduce web programming. That is still writing code ultimately, but whereby the user interface is now going to be a browser or even a mobile device ultimately. To do that, we're going to introduce you to first some fundamentals of how the internet works itself. Right. Then we'll transition to a language, but not technically a programming language, called HTML, Hypertext Markup Language, followed by another language, though also not a programming language quite yet, called Cascading Style Sheets, and ultimately we'll reintroduce some proper programming so as to automate much of what we'll be now discussing. But first, let's begin with what underlies the World Wide Web, or web for short, which is the internet itself. And it's perhaps simplest to think of the internet as like the underlying plumbing that allows us to get data from point A to point B. So there's...
Is the audio, it's a little loud? Okay, sorry. I turned it down, and let me know if my voice it needs to come up as well. I'm trying to get these levels right. Thank you guys so much for helping me out here.
lots of computers in the world nowadays. They are all physically connected somehow or virtually connected with wires or wirelessly. And if you can imagine each of those computers somehow being able to talk to one another, that then is our internet, an internetworked set of computers that can somehow intercommunicate. But it wasn't always that way, even though you and I take for granted the fact that we can all talk electronically nowadays online. Indeed, early on, there were only a few points of presence on this here internet. So for instance, here is the United States in 1969 when ARPANET, which was developing what we now know as the internet. And there were only a few locations here, primarily on the West Coast. And those universities initially were indeed able to intercommunicate, sending the first emails, for instance, even before there was a World Wide Web. Eventually, some other universities came online, Harvard, for instance, among them on the East Coast of the United States. And then East Coast and West Coast were suddenly able to intercommunicate as well, as with emails and the like. But in order to get data from point A to point B, so to speak, in this case, West Coast to East Coast, not to mention the rest of the world, once more and more servers were introduced to this mix, we needed to somehow route the information. And so one of our first terms of art today will be that of routers. Routers are simply computers, or technically servers, whose purpose in life is to route information from one point to another. Now, these servers might look a little different from your laptops and phones, certainly. They might look different from your desktop PCs, but they're still just PCs. Computers that maybe have a different form factor, a different shape, but that typically live in what are called data centers, like big warehouses that store lots and lots of computers. Those computers have lots of cables that interconnect them with other computers there, as well as other warehouses and data centers, much like the dots you just saw on the screen. But the software that those servers are running give them the ability to route information from one location to another. So if I here am representing the server, essentially these devices need to decide when they receive some information, an email, a web page, or the like, does it go this way, or this way, or this way, or this other way? And they use software to figure all of that out. Now here we have a visualization in the spirit of using Zoom from some of our former teaching fellows who acted this out. So if you can imagine a teaching fellow named Phyllis wanting to send, say, an email to a teaching fellow whom you might know, in fact, named Brian, well, Phyllis might put that message in some kind of envelope. Here physical, but think of it as virtual as well. And she's going to hand that envelope off to the next router near her. And maybe it's above, below, to the left, or the right. But generally, this envelope is going to take some path from point A, Phyllis, to point B, no pun intended, Brian. Let's take a look.
I don't want to play the music. Let's turn that off. Don't want to get YouTube in trouble here. We're passing the note from Phyllis to Brian. Oh, we skipped all those people.
Wonderful. So many thanks to CS50's team for making that visualization possible and how well it worked, getting the data up, down, left, right from Phyllis to Brian ultimately. But how were those teaching fellows, how were those routers making decisions? Well, in this case, we actually practiced quite a bit. But in the real world, it's all dynamically figured out via software in some form. And the language that routers typically talk in order to figure out how to get from point A to point B is a language, or really a protocol called TCP IP, which is technically two protocols together that each do a little something different. And in fact, let's focus on the one that's probably generally familiar to many of you, namely IP. So even if you're not a computer person, odds are at some point you've heard of IP, perhaps in the context of an IP address. IP stands for Internet Protocol, and you can think of this as a language or a protocol, to be more proper, that computers speak when trying to send information between each other. And a protocol is really just a set of conventions. And so, for instance, in the human world, much of it, if I were to extend my hand to you upon greeting you for the first time, most likely, depending on where you're from, you would know instinctively to reach out with your hand and shake my hand, completing a human protocol. So it's not so much a language that we're speaking, but a set of conventions. And indeed, that's what TCP and IP are. But IP is very specifically focused on addressing servers in the world. So what do I mean by that? Well, it turns out that every computer in the world that's connected to the internet has what's called indeed an IP address, a unique identifier that typically is of this format: something dot something dot something dot something, where each of those somethings is a number, a simple integer. Those integers are typically 0 through 255, which is to say that you have 4 values in a typical IP address that's between 0 and 255. If you're doing some mental math now, you might recognize those numbers. Anytime you're counting from 0 to 255, you're using 8 bits, or 1 byte, which is to say that an IP address, as represented here, with these hash symbols, is 32 bits in total, or 4 bytes. So your mind can immediately start to wander, if you do some of that mental math, to conclude that, oh, it would seem that you can have no more than, per past discussions, 4 billion IP addresses, because 2 to the 32nd power gives us 4 billion, especially if we don't have to worry about negative numbers, which is to imply that there can only be 4 billion devices on the internet in total. Now that's a lot, but there's also a lot of humans in the world, and there's a lot of humans with multiple devices, laptops, desktops, not to mention all of those servers and Internet of Things devices. So the world not only uses this format nowadays, which is technically called IP version 4, there's also a new and improved version of IP addresses known as IP version 6, which the world is starting to use, especially some of the bigger companies and internet service providers out there. But odds are your computer and my computer still tend to use IPv4, this format. So we'll focus on this one, if only because you're likely to see it in the near term in the real world as such. So how does this all work? Well, this is perhaps the most cryptic looking diagram I could find that represents exactly how IP works. Now, this is sort of ASCII art, and this is actually a diagram from the specification, or RFC, request for comments, that defines how IP, the Internet Protocol, is supposed to work. And what this diagram is implying is that anytime you want to send a message over the Internet using this protocol called IP, you first have to make sure that you write an address on the envelope, and you write another address on the envelope that is your sender address or source address. And the way you do this, of course, is not something physical in an envelope, but rather you use a sequence of bits that indicates what the source IP address should be and what the destination IP address should be. And then let me wave my hand. There's a whole bunch of other bits being used anytime you send information on the internet, in addition to that source address and destination address. So this, though, is essentially written on the outside of this envelope in this here way. Now, what does that really mean? Well, let me make this a little more concrete. And just for the sake of discussion, suppose that Phyllis, in our example, was sending indeed an envelope virtually to Brian from point A to point B. Then let's suppose, for the sake of discussion, that Brian's IP address is a number like 1.2.3.4. So metaphorically, what Phyllis would do, or really Phyllis's computer would do, is write that IP address right in the middle of the envelope, just like a human would when addressing a letter in the real world. But so that Brian could potentially reply to her, either with new information or at least to acknowledge receipt of this same envelope, she's also going to put her IP address in the top left corner, and maybe her IP address is 5.6.7.8. Suffice it to say, I'm making up these numbers to keep them simple, but they could be actual IP addresses because they fall into that format of something dot something dot something dot something. And so now when Phyllis hands this envelope off to the person or the router next to them, next to her, that router can look at the same envelope, realize, oh, this is going to address 1.2.3.4. I might not be physically next to Brian, that IP address, but I can at least hand it off to some other router that might be closer to Brian and therefore know how to get it to him eventually. And so what routing is all about is exactly that. These servers passing off, metaphorically, these envelopes back and forth, ideally getting them closer to their destination. Now, unlike the real world, where the shortest distance between 2 points is a straight line, you might recall that Phyllis didn't actually hand that envelope up and to the right diagonally to Brian. Rather, it went up and down, and it didn't necessarily follow the shortest path. But in the real world, routers might at least ideally route data in the fastest way possible. So even though they might traverse geographically disparate routes, sometimes because the servers are faster or less busy, it might make more sense to spend a little more distance to get the data there based on how the servers are configured. And also finances might be involved. There's a lot of big internet service providers in the world, the Comcasts, the Verizons of the world in the United States, for instance. They might have relationships with other internet service providers such that they want to ideally keep data on their network so as to not to have to pay fees to route the data on someone else's network, so to speak. So there's lots of ingredients that go into deciding how to get the data from point A to point B. But in general, it doesn't really take more than 30 hops, so to speak, 30 passings of the envelope from router to router, because at that point, it's probably stuck in a loop if it's going on for more than, say, 30 such hops. So what's really written on the envelope is more arcane information like this, but it's just patterns of bits. So it's as though Phyllis was just writing patterns of zeros and ones on this envelope that adhere to this pattern, and then inside of the envelope is what Phyllis might actually want to send Brian. Now, what might that be? Well, as you know, the internet is filled with cats. And for instance, here is one such picture of a very happy cat. Unfortunately, it's a pretty big picture. And if you can imagine this being maybe a video instead, it would be even bigger in terms of its file size, even more bytes. And so what computers typically do is they additionally fragment information when they're sending it on the internet. So rather than try to shove this big cat inside of that envelope, what a computer would do, even though this feels a little sacrilegious, would be to tear happy cat in two, maybe even into 4 parts, and then put each of these fragments inside of an envelope, followed by another fragment inside of another envelope, at which point, to be fair, Phyllis had better address the second envelope as well, probably with the same amount of information. So she would probably put 1.2.3.4 on the middle of the envelope, and 5.6.7.8 in the top of the envelope to indicate that this one, too, is destined for Brian's IP address as well. Unfortunately, once we start chopping things up into fragments like this, it's no longer sufficient for the outside of the envelope to indicate only the destination. Because what if they arrive in this order, or maybe this order, or some other order altogether? After all, there's nothing stopping Phyllis from handing one envelope here and another envelope here, so long as they eventually make their way to Brian. So he's going to need a little more information in order to reassemble this data at its destination and know ultimately just how many total envelopes were sent to him. So how can we go about doing that? Well, let me propose that we introduce another protocol as well that will help us guarantee delivery of this information. So there's this other protocol, TCP/IP, and it's typically written or said in the same breath as IP, such that we talk about TCP/IP, but it's a separate protocol. And TCP's purpose in life is to solve a few problems. For instance, among the problems that TCP does for us is it ensures that we acknowledge exactly how many envelopes were sent. So for instance, on the outside of this envelope, we might write not only the destination and the source address, but I'm also going to say something like 1 of 4 in the memo field of the envelope. We don't often use this in the real world, but if you were to, you could put it down there. And then in the other envelope, I might write 2 of 4. And so that now Brian, upon receipt of that, can see that, oh, this is the second such envelope. And I could keep doing this for number 3 and number 4. And what this allows Brian to do ultimately is not only confirm that, OK, I got pieces 1 and 2 and 3 and 4, he can also infer if he's missing any pieces, lest he have a very unhappy cat that's missing an entire quadrant of that there picture. So TCP accordingly can help Phyllis guarantee delivery by establishing an additional protocol on these virtual envelopes that dictates that we also keep track of the sequence numbers of these here envelopes so that Brian can infer if anything has been missed. Otherwise, he can acknowledge, thank you, Phyllis, I got all 4 of these. But there's another problem that TCP solves for us, which is that the internet itself does so many different things nowadays. We've got email. We've got the World Wide Web. More on that soon. We've got video conferencing. We've got streaming media and so many other applications that run on top of the physical infrastructure that is the internet. So what else does TCP do? It also defines a convention for what we're going to call ports. A port is simply a unique numeric identifier for a specific internet service. And years ago, a bunch of humans decided to standardize what these port numbers are. So for instance, a bunch of humans in a room decided that, you know what, to uniquely identify World Wide Web traffic, let's use port 80. So the number, the integer 80. But if it's securely sent using not HTTP, but HTTPS, more on those also a bit later, then it's going to use port 443. And there's other numbers as well. 25, for instance, is commonly used for email. 53 is commonly used for DNS. And there's other integers as well, much longer list than the two here on the screen. What Phyllis can then do is if she specifically wants to request a web page of Brian, whereby Brian is now not only the recipient, but a web server that has pages of content, what Phyllis can do on the outside of this envelope is add essentially a colon and then a port number, such that now the destination is still 1.2.3.4 colon 80. And this indicates that when Brian receives this envelope, he, as a server, knows that this envelope is destined for not the email server, not the video conferencing server, not the streaming media server, but rather for the web server that happens to be running at Brian's location. And in fact, this is because, as an aside, when we talk about a server, singular, can actually do multiple things. A single server can handle email and web and video conferencing and more. And so what these port numbers ultimately allow servers to do is to multiplex, so to speak, or distinguish which server or which type of service should be handling this inbound request, so that Brian replies with a web page and not, for instance, an email or something that's inappropriate like that. Meanwhile, if we want to get our hands a little dirtier with the underlying format of these things, even though I wrote it on the outside of the envelope as just colon 80, what's really happening underneath the hood is a little something more complicated like this, whereby Phyllis would write not only a destination port, but also a source port. So it turns out even Phyllis uses a unique identifier so that Brian knows how to address his response to her specifically. And there's that sequence number and the acknowledgement number that I alluded to earlier, whereby TCP ensures that we can keep track of 1 of 4, 2 of 4, 3 of 4, 4 of 4. So long story short, what TCP IP together allow us to do is uniquely address computers on the internet, as by using IP addresses in a standard way, and to guarantee delivery of data between 2 points by using these sequence numbers and as well as these port numbers to make sure that the data gets where it needs to go. Now, I'm using guarantee a little bit generously. If the internet goes down, the power goes out, TCP is not going to get data from point A to point B, but assuming the internet itself is working, that is what these protocols together do. But to recap then, with TCP IP, we have this mechanism for addressing computers uniquely, much like we do already in the real world. And in fact, Sanders Theater, for instance, is 45 Quincy Street, Cambridge, Massachusetts, 02138 USA. That is exactly what you could write on the outside of an envelope to mail it physically to Sanders Theater. What we're talking about then with these virtual envelopes is exactly the same idea, but in a way that supports servers sending the same data. And it turns out that just dealing with numbers like IP addresses is much easier than full text like things on the outside of our own envelopes. Indeed, imagine how much happier the mail service, the postal workers, would be if all we were writing were very clean numbers on the outside of the envelopes, and they wouldn't have to read messy handwriting with much more complicated strings of text. All right, so it stands to reason then that this seems to work, at least as I've told it here. But of course, none of us probably use IP addresses explicitly every day. In fact, when you go to a website, you probably type google.com or CS50.ai or other such domain names. And yet, here I am telling this story that underneath the hood, a la Phyllis communicating with Brian, everything uses IP addresses, not to mention port numbers and sequence numbers on the outside of these envelopes. Well, suffice it to say, your Mac, your PC, your phone is somehow figuring out how to write those numbers on the envelope, even though you and I as the humans are only typing in actual domain names like google.com, CS50.ai, and the like. So how does that all work? Well, in the world of the internet, there's other types of servers out there as well. Not just routers that route data from point A to point B. There's also DNS servers as well, domain name system servers. And these typically live inside of your internet service provider's network, or on your university's campus, or in your company's office, or somewhere in between you and the rest in the world. And what a DNS server does, in short, is translate domain names to IP addresses so that you and I, as humans, can type the more user-friendly version of google.com and CS50.ai, and you and I don't have to worry about or figure out what the underlying IP addresses are. Now, it turns out the implementation of a DNS server follows a familiar paradigm. We've long talked about dictionaries now, an abstract data type that allows us to associate keys with values. Well, in the case of a DNS server, they essentially have inside of their memory a 2-column sheet or table, the first of which is the domain name, the second of which is an IP address. Technically, those domain names are called fully qualified domain names because it might be something like google.com or www.google.com or some other subdomain therein. So what it is you type would be in the left-hand column here, and what it is that gets written on the envelope would be in the right-hand column here instead. So now this table, you could imagine it being very, very big. I mean, there's thousands, hundreds of thousands, millions of domain names out there nowadays, and surely your phone in your pocket doesn't know about all of them, but that's okay, because the design of DNS is actually to be very hierarchical, so that your internet service provider probably has its own DNS server that can translate many domain names to IP addresses, especially if they're popular ones, and therefore they have looked up the IP address already in the past for their customers. But if you visit a random website that's not very popular and no one has visited at all or recently, your internet service provider can recursively ask another DNS server for the answer to the question, what is the IP address of that domain name? And in fact, around the world, there are what are called root servers, a small number of servers that, for instance, know about all of the .coms and all of the .orgs and all of the .govs, and similarly for other countries as well, whereby those servers, even if they don't know the exact IP address, they might know the IP address of another DNS server who does have the answer. And so long story short, if you've ever bought or really rented your own domain name before, or if that's something you choose to do in the future, essentially what you're doing when you pay someone some number of dollars per year to buy a domain name is you're asking them to add an entry to their DNS server or someone's DNS server that associates that domain name henceforth with a specific IP address of your server or server. So someone somewhere is doing that for you. But the whole process is indeed recursive, because if your ISP doesn't know the answer, it can maybe ask another DNS server, or maybe these root DNS servers as well. Your own Mac, your PC, your phone might itself cache or remember these answers though too, because it's a little silly in terms of design if your phone or your laptop or desktop has to constantly ask that same question every time you visit google.com. Odds are the IP address is not going to change, or at least it's not going to change that frequently. However, again, if you've ever set up your own domain name, if you've ever moved it around or something has changed about it, sometimes you can break a website by changing its IP address, because there's lots of servers in the world that have cached, C-A-C-H-E-D, or remembered the old IP address. But thankfully, the other feature that DNS provides is expiration dates. So essentially, the answer to the question, what is the IP address for this domain name, typically expires after a few seconds, a few minutes, a few hours, a few days. Unless you really mess things up and say, don't expire this for a year, then your website could in fact be a dead end somehow. So this is worth knowing for future web developers doing things in the real world. So DNS, to recap then, simply converts domain names to IP addresses, and technically it can go in the other direction as well. And so when you, as a human, go to a browser on a laptop, desktop, or phone and type in google.com, enter, or CS50.ai, enter, what essentially happens is your device checks its local cache to see if it's already been asked that question before. And if it has, it just immediately knows the IP address, writes it on the outside of the envelope, so to speak, and sends out your data. If it doesn't know the answer, your computer is going to ask the local DNS server, which might ask another DNS server, which might ask another DNS server, but recursively, you will eventually get your answer if that domain name actually exists. And at that point, your computer can indeed write the correct IP address on the outside of the envelope, add any sequence numbers, add any port numbers, and voila, it's on its way from point A to point B. Okay. So that then is DNS. How about one other acronym that's a bit related here too, that of DHCP. And let me assure that it's not really that important to memorize like what all of these acronyms stand for, but rather it is useful, I think, to generally know what they in fact do. So DHCP is Dynamic Host Configuration Protocol. So there we have it, another protocol, a set of conventions. And the purpose of DHCP is to actually give your computer an IP address when it boots up. This wasn't always the case. Back in the day, if you've had internet connectivity for a while, some technician probably would come to your house when you or your family signed up for internet service. They would probably have a sheet of paper on which was your personal IP address. And if you wanted to connect your PC to the internet, they would like type that IP address manually into your computer so that your computer knows what IP address to use when talking to other servers. That's not particularly scalable. That's not particularly maintainable. You don't want the technician to have to come out just to make a change or something like that. And you probably want to be able to use multiple devices as well. And so nowadays, what most computers use is DHCP to dynamically figure out what is their IP address. And so nowadays, when you first open your laptop in the morning or boot up your PC or take out your phone, if you haven't used it in a while, and therefore it no longer has an IP address because these two expire after some amount of time, your phone, your device will broadcast a message like, what is my IP address? And hopefully, on the nearby network, in your home, in your company, at your university, or in your internet service provider more generally, you will hear an answer, oh, use the IP address 5.6.7.8, for instance, in the case of Phyllis, or 1.2.3.4 in the case of Brian's recipient address as well. So the people who run these servers, the internet service providers of the world, the system administrators at your company or campus, they can come up with the rules via which these IP addresses are assigned or who gets what number. But ultimately, DHCP is just another protocol that governs how your device gets its IP address. But that's not quite everything. It's actually kind of neat. DHCP servers also tell your computer what DNS server to use. They give you the IP address of one or more DNS servers to ask questions of. DHCP servers also tell you the IP address of your default gateway, the router that you should use by default to hand one of those envelopes to. And this is indeed why Phyllis probably knew to whom to hand that envelope in the first place, because when she booted up, so to speak, she was assigned an IP address, she was told what default gateway to use, and the default gateway, aka router, these are just synonyms, is the device to which she should hand off data by default in order to get it from point A to point B. So why do we focus on all of these acronyms, all of these technologies? Well, on the one hand, they're sort of omnipresent. And even though you might not need to say these acronyms verbally all that often, you're going to see them on occasion. When something goes wrong, you're going to need to troubleshoot things like this. But more importantly, they're sort of representative of very real-world engineering problems that the world has had and encountered over the years. But they're relatively simple solutions there, too. You know, I don't necessarily know how I could write code to implement a DNS server or DHCP server, and perhaps neither you, but it sounds like a pretty simple idea. If I have the ability in code to hear requests, I can respond to those requests by maybe using a dictionary in memory, and in the case of a DNS server, and responding to those answers. So this is to say all of the fundamentals, all of the ideas we've been talking about throughout CS50 really are used as building blocks to solve these very real-world, very omnipresent technologies that you and I now take for granted every day. Let's now consider one other protocol that's with us every day nowadays, that of HTTP, Hypertext Transfer Protocol, which is indeed itself a protocol, a set of conventions that governs, in this case, how web browsers and web servers intercommunicate. It is very much related to HTTPS, which is literally the secure version thereof, that somehow uses encryption, somehow scrambles the data to ensure that when you're visiting a web page, you and only you can see that web page, and no one in between you on the internet actually knows what it is you're looking at or the specific URL that you are visiting beyond the name or the IP address of the website itself. So even though you and I probably don't even bother typing http:// or https://, odds are nowadays you and I just type google.com, enter, cs50.ai, enter, or you click on a bookmark. Underneath the hood, this protocol is everywhere, and those prefixes, HTTP and HTTPS:// are required when using a browser, even though your browser automatically tends to insert those prefixes automatically if you, the human, don't bother typing them yourself. So they're used, of course, in URLs, Uniform Resource Locators, which specifically are the addresses that we use to get to useful information on the World Wide Web, or web for short. Here, for instance, is one of the simplest URLs we can talk about. I'm going to use HTTPS deliberately to imply that you really do want to try to use secure sites alone nowadays. But this domain name would seem to be www.example.com, or that's the fully qualified domain name itself. But let's tease apart what's going on here. Typically, in your browser, you might see a trailing slash, so a forward slash at the end of it, which just indicates, albeit non-obviously, that you want the default web page at that domain name. In particular, you want to be able to access whatever the default content is for that website. Nowadays, though, browsers like Safari and Chrome and even others tend to hide these details just to simplify what you're actually seeing in your browser. But typically, if you click or double click on the URL bar in your own browser, you'll see more information, including this trailing slash. So if you only type in google.com, enter, probably your browser is automatically appending the forward slash to indicate you want the default home page. But sometimes there's more to the URL. Sometimes it's slash path, where by path I just mean a folder or a file name or something along those lines. And that's more specifically referring to like probably a directory on the server containing some web page specifically. Sometimes it's more explicit. Sometimes the URL might literally end in .html, which is going to stand for Hypertext Markup Language, one of the first languages we'll soon look at in detail. And that's the language in which web pages are written. So what this URL indicates is that at the server called www.example.com, there is a file called file.html that this user wants to see in their browser. Sometimes, though, and it's not often the case anymore that you see these file extensions. The world decided years ago that these are just kind of ugly and not strictly necessary technically. So sometimes you'll just see slash folder slash, which just means there's a folder, aka directory somewhere on the server, whose web page content you want to see. Sometimes it's nested. Sometimes it's a folder and then a file inside of which is the web page contents that you want to see. So in short, URLs generally follow this kind of format, and there might be 0 or more of these folders and maybe a file name explicitly or not. But what else is going on here? Well, here we have the fully qualified domain name. And just to toss out a bit more jargon, technically when you say domain name, typically you mean something like this, just the example.com. Because the www in this context is generally referred to as a host name. It's like the name of a specific server at a company, at a university that is providing some service like this, the World Wide Web, aka a web server. It is not strictly necessary for a server to have a name of www just to be a web server. For many years, MIT's website was web.mit.edu, whereas everyone else in the world was using www. But odds are many of you are probably not even in the habit of typing www.something.something. Rather, you type in google.com and hit enter, and the browser somehow automatically brings you to www.google.com. So the host name is the name of a specific server. The domain name is typically just something like theexample.com. And let me disclaim, that's a bit of a white lie, because if you're Google, if you're Meta, if you're any of these big companies, you don't just have one web server. So technically, the www refers to a collection of servers. Maybe it's 2, maybe it's 20, maybe it's 20,000 servers. There are technologies that allow you to support that as well. But lastly, there's one other piece of jargon that's worth knowing. The last part of these fully qualified domain names is known as the TLD, or top level domain. And that is what generally, historically indicated what type of domain it is. In the US, .com means commercial, .gov means government, .org means organization. However, there are so many more top-level domains nowadays, and in fact, they're not US-centric. And in fact, just because you have .com does not mean you are in the US. It just means that you paid someone to use their domain name. In fact, there's other TLDs too. Every country has its own .us for the United States, .uk for the UK, .jp for Japan, and so forth. Anytime the TLD is just 2 characters, that's a country code. And yet that's kind of curious because we're in the habit of using CS50.ai. There are websites that use .tv. There are websites that use .io, CS50 included. And if you'd like to go down that rabbit hole, feel free to Google top-level domain, or TLD, and any of those. And you'll actually see that even though we are using CS50.ai to imply artificial intelligence, .ai has nothing to do with artificial intelligence, except that that is how you can abbreviate it in English as an acronym. It actually is a 2-character country code. And that country and others have decided to actually monetize the TLD by selling it to really anyone who's willing to pay per year to use their TLD. So lastly, within these here URLs, we of course have the actual HTTP or HTTPS, and that dictates the protocol that is going to be used when a web browser requests a web page at their address. Now, what does this protocol do? It's similar in spirit, again, to sort of a handshake, whereby a web browser, when it wants a web page, it's kind of like extending a hand, hoping that the web server will respond and know what to do. Of course, there's no such handshake physically here, but rather, metaphorically, the web server should know how to respond so long as the web browser standardizes the message that it sends. So what do I mean by that? Well, let me propose that inside of this envelope can be one of two messages. And this is a bit of a simplification, but the first of those messages is get. And what get means is literally get me a specific web page. By contrast, you can use post inside of these envelopes, and post generally means to send information somewhere else. And this too is an oversimplification, but generally the word get is used by a browser when it just wants to get information. The word post is used when it wants to send information, often sensitive information like a credit card, an email address, a password, or anytime you're sort of filling out a form, it's generally sent via the post keyword instead. And these are indeed verbs, like get and post are both verbs in English, implying that this is some here action. Now, ... means that there's other verbs that can be used inside of these envelopes as well, but let's be more specific. Inside of the envelope that's being sent from browser to server is more specifically a message like this. So if I, with my browser, visit www.harvard.edu, the message that goes inside of that virtual envelope, as we discussed earlier, is literally text that looks quite like this. So the cat is gone. There's no more pictures of cats just yet if you're just requesting Harvard's own homepage. But inside of that envelope is indeed get/http/to, for instance, then host, then the actual host name or fully qualified domain name that you are seeking. And ... There's some other stuff there, but that's what's inside of that envelope. Hopefully, what's going to come back from the server is another envelope inside of which is a response. So whereas the first message is a request to get something, the response is indeed a response that hopefully contains the actual web page that you requested. And you'll see that the response might look like http/to, 200, and then content type text HTML, which just means that the web page is written indeed in this language we're about to spend time with today, HTML, below which is the actual content. So how can I actually go about seeing some of this? Well, let me actually go over to VS Code. And up until now, we've been using VS Code for the purposes of writing code. But we do have this terminal window. And the terminal window gives me access to an underlying operating system. That operating system, recall, is called Linux. And I have a command line interface here. And up until now, I've been using this command line interface for commands like cd and ls, make, debug 50, Python, SQLite 3, and the like. But there's other commands that typically come on a system, including this one, that allows me to make internet requests as well. Not even with a browser, but textually. Moreover, there's always been, even though I generally hide it during class, a second tab, namely ports. And if you yourself look at cs50.dev after logging in, odds are you will see a ports tab, among others. And what you'll see here is that all this time, CS50's own development environment has been using by default a TCP port number, namely 1337, which is a very elite number for us to use. And that is the port number that's used by CS50's customizations of VS Code. Our so-called extension uses that TCP port number so that when our extension is talking to VS Code, it uses a standard port number on the outside of its own virtual envelopes, if you will. You as users don't need to care about that, but that's why that tab, all this time, if you've seen it, has had numbers in there. And soon we're going to see some additional numbers as well. But if I go back to my terminal window here, I, of course, could type commands. And one of the commands I could type is actually this. Let me increase the size of my terminal window. Let me go ahead and type curl, which means connect URL, -I. And now let me go ahead and type in https://www.harvard.edu/. So I'm going to manually type this into my terminal Windows command line interface and see what comes back. I'm going to hit enter. And I get a bunch of stuff back. That's why I used a ... on my slide a moment ago. But in this output is some familiar text now. One, we saw this line earlier on my slide, http/to, and then some number 200. And then there are other lines here that I waved my hands at earlier because they weren't strictly necessary, including the host line. If this server is only doing one thing, we don't even need to clarify that this is www.harvard.edu/. harvard.edu. But what then is this HTTP/2 and this 200? Well, it turns out that the 2 is just a version of HTTP that my browser or my keystrokes were using a moment ago. 1.1 is a common version number, 2 is a common number, 3 is catching on over time, but this just indicates what version of the protocol the browser and server are speaking, even though this browser has no graphical user interface. It's just a command simulating a HTTP request to get back these headers. And that's in fact what -I means. Show me just the headers. I don't want to see any cats or Harvard News. I just want to see the headers inside of the envelope. But it turns out all this time, for as many years as you've been using a browser, you could actually do this in your own browser as well. Let me open up another tab here, and let me manually go to https://www.harvard.edu/enter. And what I'll see here is Harvard's homepage as of right now today. Okay. It all worked as you might expect. But it turns out all this time you've had access to some powerful tools underneath the hood. Let me actually right-click anywhere on this web page and select Inspect. And that's going to open what are called developer tools in the context of my browser, which is Chrome. Most every browser nowadays, Safari, Edge, and others, have similar looking tools, though you might have to access them via different menus. And in fact, in Chrome, you can also go up to the ... menu and find your way to developer tools. But there's a lot going on here. But what I'm going to do is go to the network tab here for a moment. And I'm going to zoom in just for the sake of legibility. And notice here that when I clear this network tab, this is giving me access essentially to a log of everything that you're about to see on the screen. And notice it just undeleted itself. Apparently, Harvard is doing something behind the scenes every few seconds, which is why that row reappeared, because indeed, I'm trying to record my network activity. But let's go ahead and do this. Let me clear that one more time and reload the page, and so many rows just flashed across the screen. In fact, in the bottom left-hand corner, you'll see that my browser, unbeknownst to me, made not one, but 67 HTTP requests. That's how many envelopes essentially went back and forth between my browser and harvard.edu a moment ago. Here comes another, and if we just keep this open, it's going to come again and again. Harvard is kind of keeping the page alive. But let me zoom out and scroll back to the very top of this and focus on just the first page I requested, and click on www.harvard.edu, and let me click on headers here. What I'm seeing is diagnostic information, if you will, about what I just did. And you'll see that the URL I requested was indeed this thing here. I used a request method of get. Unbeknownst to me, get is what is used by default when you just type a URL and hit enter. Then the status code that came back, there's that 200. So it turns out that what web servers and browsers have done over the years, thanks to HTTP, is they have standardized what these numeric codes are to indicate success or failure. In the world of programs that you and I have been writing, we typically use 0 to indicate success and maybe 1 or 2 or some other integer to indicate failure. In the context of the web, it's kind of the same idea, but the web uses 200 to indicate success and other numbers to indicate failure or something else happening as well. Well, what else can those status codes represent? Well, let's take a look here. Notice that when I'm in my browser and I go to simply harvard.edu with no HTTPS, no : / no www, no trailing slash, enter, it all just sort of works and brings me to the intended place. Now, why is that? Well, at the lowest level, we can actually see this in our command line interface. Let me go back to my terminal window, which I've still full screened, and let me type this time curl -I, and then simply http : / harvard.edu. So I'm going to help the program a little bit and provide it with the protocol, but I'm not going to provide it with the secure version. I'm not even going to mention www. Let's see what comes back. Ideally, it's a 200 OK, because that's what means success. But what I see here is weirdly that harvard.edu has moved permanently. And this time, the status code, coming back from an older version of HTTP, in this case 1.1 instead of 2, apparently has a status code of 301. So it turns out that different types of responses indeed have different numbers associated with them. And 301 means moved permanently, a sort of redirection, if you will. And where is Harvard's new location? Well, if we scroll down among these headers, you'll see that, the server is additionally telling me that the location to which Harvard has moved permanently is https:/ harvard.edu. OK, so what this seems to indicate is that Harvard server really wants me to stay on the secure version of the website. All right, so let me go ahead and highlight and copy that. let me go ahead and do curl-i and that URL. So almost the same, except for the HTTPS this time and the trailing slash, and hit enter. But this time too, notice, and this time the server's using a newer version of the protocol. We're back to version 2. It's still telling me 301. It's not berating me by saying move permanently again, but 301 is enough for me, the browser, to know, oh, Harvard's website is now at this location, www.harvard.edu, again using HTTPS. And so, OK, let's do this one more time. Let me go ahead and copy that URL and do curl-i and that full URL. And now we're back to getting a 200 OK. So among the reasons that your browser is able to figure out what you want is because, one, the server might be telling it, no, go here. No, go here. OK, now you're in the right place. And frankly, browsers nowadays, in cooperation with servers that are configured in a certain way, will tolerate you typing in only harvard.edu and just know proactively, no, 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 you don't want that. You want HTTPS and you want the www because the browser, for instance, has seen that response before from the server.
Yeah, OK.
But at the end of the day, it's really just these status codes that are enabling us to actually forge these responses. So we've seen a couple now. We've seen 200 for OK. We've seen 301 for move permanently. There's bunches of others as well, including, for instance, this one here. Odds are most everyone here has seen 404 at some point in their lives. I mean, it's sort of in the human vernacular. We all know that 404 means file not found. Like the URL is wrong, the file was deleted, something is missing. That's a little weird that we as humans have been acclimated to a fairly esoteric HTTP status code, but that's all it is. If you visit a web page that simply does not exist, you will get back not 200, not even 301. You'll get back a similar header like this saying 404, file not found. Now, you might see a web page, and it might be a cute web page, or it might be a black and white text-only web page. It depends how the web server has been configured to show you that information, but 404 indeed means file not found. And here's a non-exhaustive list of other status codes. We've seen 200, OK, 301.
Let me write some of these down. 200, 301 means moved permanently. 302 is found. 304 is not modified. 307, temporary redirect. 401, unauthorized. 403, we're getting there. Forbidden. 404, not found. 418, I'm a teapot. Okay, now we're just trolling. 500, internal server error. 503, service unavailable. All right, we'll pause here and we'll ask them. We'll get caught up on the chat. We're 47 minutes in, over 45 minutes on this lecture. How you guys liking it so far? We're about halfway done with the part 1 that we will watch for today. We're going to watch half of this lecture today and half tomorrow. So I believe his first half is probably going to go over a lot of, internet and HTML and stuff, and then the back half will get into styling and JavaScript, I bet you. So we'll probably end up having to stop after this long chunk right here on HTML. So that's probably where we'll end up pausing this lecture after today. Hey, how's it going, everybody? Welcome in. My name is Michael. Thanks so much for joining me here. We out here? Yes, we are. Hey, Ryan. Thanks for joining me. We are live on both YouTube and Twitch right now, so if you would like to watch on either, feel free to do so. You can find the Twitch link in the description below if you're on YouTube, or look me up on YouTube if you're on Twitch. I don't have it in the... I do have it in my bio in Twitch. We are watching Harvard CS50X 2025 Lecture 8 on HTML, CSS, and JavaScript. We started this course back in... January 1st, 2025. And so we're already on week 8, so we're making a lot of really good progress. We've learned a lot of really cool stuff so far, like basic C syntax. Got a lot of practice, with basic C, understanding its syntax, its needs, its loops, it's how you make functions, how you call functions, all these kinds of things in C. We then transitioned into Python from there. That was a good refresher. We flew through that week, but then after that, we went and did some SQL work, and now we are learning some HTML, CSS, and JavaScript. So we haven't done a ton of programming the last week or so, so it might feel like we haven't done a lot of learning in programming, but we did learn a whole thing of SQL, how to make queries and things like that. But this week is going to be pretty programming heavy, I bet you, as we're going to be coding in three separate languages, I guess. Let's get caught up on some chats here. Hey Gene, how's it going? Hey Ryan, Trash Ketchum, welcome back. Keep cool. Welcome back, dude. You can do this. Trust me, you can do this. I often trust me. It's a battle to come in, to sit and study every single day. I'd much rather be going and skateboarding or playing my guitar or hanging out with my dog. But I just enjoy coding, and with coding, it comes with having to learn, and with anything comes hard work, especially if you want to accomplish something. So use this stream as motivation. Keep cool to join along here, and if you see me studying, pop in and watch the stream and study along with whatever, if you're following along directly with what I'm doing here, or if you're just having the stream in the background, like we're hanging out and we're just working on studying stuff together. So thanks for coming and keep cool. You're awesome. Yeah, David's cooking right now. I'm in my junior year of high school, keep cool says. Haven't found the time and motivation. You definitely got this. Machine learning engineer, you can do that for sure, man. I believe in you. Well, this is a great place to be. We are on week 8 web dev here at Keep Cool, so people say 403 means all ports open. Hey, Smoking Noir, how's it going? Hey, Keep Cool. People saying cool, hey, because I paused the video. Hey, Natty Sanis, welcome in, you guys. Hope you guys are enjoying the stream so far and the video. I know I haven't been pausing it for much chatting because I don't want to interrupt and have this lecture take forever. We're only going to watch up to this middle portion here, and then we'll watch the back half tomorrow. Got a code 500. The doggo is still with my girlfriend right now. She hasn't been able to make it back since she got back because she's been borrowing my car because remember guys, you guys aren't familiar, when I went on my vacation, someone broke into my girlfriend's place and stole her car. So that's the only thing they took. They stole her car, they stole her oat milk, they drank all of her oat milk, and they stole her cheese. So and then they actually found her car at the bottom of the river. And so they pulled it out at the bottom of the river, and so she went over there and said, yeah, this is my car, this is it. And there was like a spoon and some stuff in the cup holder. So the guy was shooting up or whatnot, and in the car, and I have a ring footage camera of him from the from the break-in of him, he was sitting outside the front door on the porch there for 20 minutes, just nodding off before he decided to go bust in and steal her car. But yeah, so she's got a loaner car right now. She was borrowing my car. She just picked up a loaner, and anyway, so I'll get mine back soon. But she hasn't been able to come back and bring my dog back because of that. So she's just been watching her. They're having a good time, going on lots of walks and stuff. But yeah, so it was crazy. They robbed and GTA, real life GTA over here. In full. Yeah, maybe he'll get booked up, huh? Food's expensive these days. Yeah, Ryan, isn't that crazy? No, not the oatmeal. The oat milk. He chugged the oat milk, left the carton on the ground, stole the cheese, and stole I think took some other food, but literally didn't take anything else out of the house, but stole the car. So, and crashed it. And yeah, he had 5 stars. He crashed it in the bottom of he sent it to the bottom of the river, and so they pulled it out, and so we're going through insurance right now to help get that sorted out and get her a new car. Anyways, let's get back to the lecture here. Enough of our GTA stories here on what's going on. But All right, we're 47 minutes in. Let's keep going.
One, okay, there's other 300 level status codes that generally refer.
Let me just grab a quick refill really quick and go to the restroom really quick. We're kind of at the halfway point between the halfway point, so just give me 1 second. We're binary. I was gonna make some lame computer science joke about binary search there, or binary search. Yeah, log two. We're gonna get through this lecture in log n time. There we go. BRB. Hold up. Let me just quickly. My, what about my drink? I forgot my drink. I thought I forgot it, but it's right here. My diet, Dr. Kelp. What about my drink? Come on, you guys got a good SpongeBob impression? What about my drink? My diet, Dr. Kelp. That's all I got. All right, let's get started and let's get back watching this lecture, guys. Bro, I want to know what it felt like to live on the van by the river, I guess. Bro at 5 stars. Stealing oat milk is devious. Hey, Tim Duncan, welcome in on the Twitch. Appreciate you jumping in on the Twitch and saying hello. You're awesome, man. All right, we are on Twitch, so if you guys want to watch on there or follow along on Twitch, you can find that in the description below, as well as my Discord. I provide all weekly updates, so I provide a breakdown of what I learned that week, links to all of my resources that I used that week, and then the links to my solutions and my problem sets within my Discord completely for free for you guys to reference in there. Van by the river? Is it just like kind of like one of those old-timey books? I don't know. Like kind of like Where the Crawdads Sing, or like Of Mice and Men, you know? That's kind of what I took it as. Down by the river. Ryan is doing double feature here on the Twitch and YouTube right now. He's really supporting. All right, let's get done. We got to keep going.
Redirecting the user from one URL to another. The 400s generally indicate user error, like your fault, my fault. So 401 is unauthorized, 403 is forbidden, like you haven't logged in properly, 404 is not found. 418 is actually an April Fool's joke from years ago. I'm a teapot was sort of a funny joke among engineers. More on that if you Google it if you'd like. 500 range errors means server error. So someone screwed up, maybe not you, but frankly, in a couple weeks' time, when you're writing web-based applications yourself, anytime you see a 500, it is your fault also. So you are both the user and the server in that there case. But long story short, the way these things work are simply underneath the hood via these status codes, which really are being sent virtually inside of envelopes like these. Your browser is generally hiding that detail because normal users don't need to care about this level of detail. But you've always had the power of opening your own browser's developer tools and poking around and seeing these things. And all I'm doing in my black and white window here with curl, which connects me to a URL using a command line interface, is showing you even more in detail what's inside of those envelopes. But it's just another way of viewing the same kind of information. Now we can actually have a little bit of fun with this, with a smile and a wink to our students at Yale who are perhaps watching this now. It turns out, has anyone ever been to this URL here? safetyschool.org. I'll zoom in here in a new tab. Has anyone applied to safetyschool.org or visited safetyschool.org? Well, we love them equally, but turns out if you go to safetyschool.org, you end up at this here website, which if I zoom back in is apparently https://www.yale.edu. So what is going on there? Well, I could open my developer tools, but let me use my newfound command line skills and do it here. curl-i http://safetyschool.org, enter, and you'll see that, oh, safetyschool.org has moved permanently to Yale.edu's own website. So this is to a practical joke that has lived on the internet for years. There is someone out there, I don't know who they are, they have been paying an annual fee for years now simply to have this esoteric joke for us computer scientists. There are ones for Harvard as well, in all fairness, but this is one that's perhaps been around the longest. So somewhere there's a Harvard alum who's getting older and older, but is still paying this bill year over year since the web was invented. All right, we're back, and we now focus on HTML, hypertext.
All right, we'll take a sec there to catch up on chats. We're going to HTML here. HTML. All right, you guys know HTML much? Any of you guys use web dev in your daily, day-to-day life? I know a lot of people were excited to learn HTML or get into HTML with this course, so let's get going here. Pardon me. Talking a lot. All right. Let's get going.
Markup language, which is the language in which web pages are written. It is not a programming language, and as such, we won't need to spend all that much time on it because the basics of HTML are fairly straightforward, even though it has a decently large vocabulary, different features that you'll pick up invariably over time. What HTML does have fundamentally are what are called tags and attributes. These are the basic building blocks of the language, and what the language looks like is this. So here is perhaps the simplest web page that I could come up with, a hello world web page, if you will, and it's just text. It is text that's typically stored in a file, like index.html for short, and in that file would just be these lines of code. And these lines here are going to indicate to the browser what it should do upon receipt of an envelope containing this message. Now, how are we going to go about serving up this content? Well, ultimately, we just need to put this content on an actual web server. Well, it turns out you already have a web server, even though you haven't been using it as such. In other words, when you visit cs50.dev and use VS Code in the cloud, you're obviously using a browser, but you're less obviously using a web server that is serving up a copy of VS Code to you in that browser. But the caveat there is that by default, you've probably been in the habit of typing cs50.dev, enter, and you've probably noticed, if not prior to today, after today, that the full URL ends up being https://cs50.dev/ and then maybe some other stuff after that. But implicit in that URL is one of those port numbers that we saw in TCP, either 80 or 443. Because it's HTTPS, it's actually the latter, 443, which indicates implicitly that there must be a server on cs50.dev that is listening for requests and is serving up that version of VS Code. In fact, we eventually redirect you to GitHub's version of VS Code, aka code spaces, but the idea is the same. And in that URL, you have a web page that's being served up to you, but it's already running on port 443 and perhaps 80. Which is to say, if we want to come up with our own web server, we could like start up our own server, connect it to the internet, give it an IP address, and then communicate with it using port 80 or 443. But it's actually a lot simpler to embrace the reality that any server can have multiple services, be it web or email or video conferencing or the like, or heck, 2 different web servers. And so even though VS Code in the cloud is already running a web server, because that's indeed how it works, there's nothing stopping you and me from inside of VS Code starting a second web server, so long as we choose a different port number, a different TCP port that's not already being used by the server itself. So how are we going to do that? Well, we're going to introduce you to a new command today, called quite appropriately http-server. This is a command that you can run in your terminal window that will start your very own web server by default on port 8080. 8080 isn't that special, but it tends to be a convention. Whenever you want to run a web server on a port other than 80 by default, you would just use 8080 as a go-to. But it could really be any number within a large range. Now, this http server command is going to allow me to serve up some actual content. What might that content be? Well, let me go ahead and do this. Let me go ahead and run code index.html, and let me go ahead and whip up a very simple web page herein. And I'll explain in just a moment what these lines are, but let me go ahead and just kind of transcribe it in this here file. So angle bracket, exclamation point, doc type, HTML, close bracket. Then I had HTML lang equals quote unquote en. Then I had head. Then I had title, and inside of that title, I had hello, comma, title. Below that head, I had open tag body, inside of which I had hello body. So there's a lot of weird stuff going on here if you've never seen this before, but I think I have recreated the file you just saw in slide form a moment ago. What I'm now going to do is try to view this file inside of my browser. But to do that, I need to do this. I'm going to go ahead and run HTTP server, enter, and a whole bunch of stuff is going to appear in my terminal window, some diagnostic output, a URL, and the like. But in particular, I'm going to get this little pop-up that's telling me, oh, my application running on port 8080 is now available. This is just a user-friendly feature of VS Code, specifically CS50's own extension therein, that allows me to click Open in Browser. I immediately get a second tab inside of which I see the contents of my code space at this moment in time. Now notice, to save myself some time today, I've downloaded in advance a source 8 folder inside of which are a lot of today's examples if I so need them. And there's a file I literally just created called index.html. What you're seeing here is a directory index of my current folder. So this is a dynamically, automatically generated web page that's simply showing me in a web browser what is inside of my code space. Now, what's my URL? Well, it turns out it's going to be something that ends in github.dev, which is a domain that GitHub itself controls. So that's going to be generated for me automatically. It's not a domain name I had to buy or sign up for. And it's really meant to be temporary because I'm going to use my code space as a development environment to develop web pages. But most important for now is that indeed this server program is running on localhost, which is a nickname for the local computer, no matter what its actual name is, specifically on port 8080. And this is why I'm now seeing my folder instead of VS Code. This tab has port 8080. This tab would appear to have port 443, which is GitHub's own web server running at this domain. Now I'm going to go ahead and click my index.html, and we will see what the simplest web page in the world might look like. And voila! There is my hello body, which is the only thing in this otherwise big white rectangular region, otherwise known as the viewport of my browser. And if I zoom in at the top here, you'll see that my title of my tab is indeed what we saw earlier, hello, comma, title. So long story short, even if you're completely new to developing web pages, clearly we have the ability with this language called HTML to indicate what the title of a page should be in its tab and what the contents of its body should be, as underwhelming and as black and white as all of this might be. Well, let me go back to my sample code here, and let's now actually introduce some building blocks herein. So what is actually going on? The first line of code that I typed, that you see highlighted here, is the page's so-called document type declaration. That's a silly mouthful, but it's really just a standardized line of text that says, hey, browser, here comes a web page written in HTML. Specifically version 5 of HTML, which is what most of the world is now using. Odds are this line of code will change over time, but for now, this is what we have. Below that, things get a little more interesting and a little more symmetric, if you will, and no more exclamation points like you see in this first line. That's a bit of an anomaly. Down here, you'll see what I'll describe as open bracket, HTML, then the space, then lang equals quote unquote en, then close bracket. And by open and close bracket, I mean a less than sign and a greater than sign, respectively, which you can type on your keyboard. What this is doing is the following. This is the beginning of an HTML element, as we might call it. Yeah. And the tag here for this element is called HTML. So anything immediately after a less than sign is the name of the tag. And the way that browsers work is by relying on these tags to know what to do and where within the confines of the browser. So you can think of this first tag as saying, hey, browser, here comes some HTML. Now, what is that HTML all about? Well, this thing here highlighted, lang, short for language, indicates what human language is presumably going to be used throughout the rest of the page. All of the tags, all of the attributes, for better or for worse, are going to be in English because the language HTML itself was standardized by English-speaking people. You can write web pages with your own content in any human language. In this case, I have opted to write my page, as simple as it is, in English as well. Hello title and hello body. And the en attribute value here, so to speak, is just like a clue to the browser that in case you've got Google Translate or any kind of automatic translation, this is a little hint as to what the human language is to facilitate automatic translation or search engine optimization, SEO, or the like. But that whole thing started the HTML page. Now we have a sequence of other tags. Hey, browser, here comes the head of the page, which metaphorically is like the very top of the page here, aka the tab that we looked at a moment ago. Hey, browser, here comes the title of my page. What's the title? The title is hello, comma, title. Now things are a little weird. The next line of text here is open bracket / title close bracket. And whereas, therefore, I might call the previous tag the open tag or the start tag, this one here now would be the close tag or the end tag. So there's a symmetry here that effectively is conveying to the browser, hey, browser, that's it for the title. The title is now complete. What comes next? Hey, browser, that's it for the head of the web page. Nothing left in there. What comes next? Hey, browser, here comes the body of the web page, sort of everything else. The big contents of that white rectangular region is the so-called body of the page. Hey, browser, here's the contents of the body. Hey, browser, that's it for the body. Hey, browser, that's it for the HTML itself. Now notice the / indicates the end tag or the close tag, and you don't need to be super verbose. Even though my HTML tag started with a language attribute, lang equals quote unquote en, you don't need to repeat the lang, you don't need to repeat the quotes or the en. It's sort of obvious to the browser that this is closing the previously opened HTML tag. Now, in general, the tags you're seeing should exist in one and only one place. You must use these tags in certain locations. We will soon see bunches of other tags that you can use 0 or more times to structure the actual contents of your own page. So how do we get into that, and what are we ultimately doing? Well, what we really have is, in this HTML code, a textual representation of a tree. One of our now familiar data structures, whereby there's a root of this tree that has some number of children, that might have some number of grandchildren, and so forth. And so depicted here at right is what you might call a document object model, or DOM, D-O-M for short, which is actually what the browser is probably doing in its own memory, or RAM, when it accesses a web page. In other words, if you type in google.com and hit enter, you immediately see the contents of Google's website in your browser. what Google has probably done is sent text that looks kind of like this, but more complicated than this simple example. That text is read top to bottom, left to right by your browser and loaded somehow into memory using malloc or other techniques like that to create bunches of nodes in memory with a lot of pointers that somehow represent this tree structure in the computer's memory so that it actually knows what to display on the screen. So with that said, let me go back here to VS Code, and I'm going to go do a sequence of examples now, and I'm going to go back to the code and then back to my browser to show you exactly what's going on. Recall that at this moment in time, the only two things I have are a source8 folder, which I came with by default today in advance in case I need to copy paste anything, and index.html, which I just created for the first time. So let me go back to my VS Code tab here, and you'll notice that in my terminal window, there's actually a bunch of logging information, diagnostic information. Long story short, anytime anyone visits a web server with a browser, odds are the server is logging that visit. In fact, this is how companies know. This is how internet service providers know. This is how parental controls know what websites you are visiting, because all of this information is going back and forth between browser and server.
They know
Here,
what
because
websites you're
I am
going
running
to,
the
boys.
server
Clean it up.
via that HTTP server
Clean
command,
it up.
I now get access to all of this juicy information, including what the browser is that the user is using, what day and time they visited my page, and so forth. But for the sake of discussion, I'm not going to really care about this diagnostic information. I'm going to hide this for the most part. But notice, too, under ports now, whereas previously I only had one TCP port in use, 1337, which is CS50 specific, now notice that VS Code has detected that I'm running something else on port 8080. So you see a second port there, and you might, over time, if you open more and more tabs, see even additional ports as well. That all happen for you automatically. So for now, I'm going to go ahead and hide my terminal window because I don't really care what's going on there, but that's still going to keep HTTP server for me running in the background. Let's go ahead and introduce some new tags. So for instance, let me go ahead and create.
Are these tags or elements? I thought these are elements. Are these tags? Bro, Smoking is just out with it. Chill, bro. Are these elements or are these tags? Anything in here is a tag, I think, Ryan says. Yeah, Script's like, bruh. Winghong parameters inside tags? I thought these are elements. He said he's like using them interchangeably. Like what's what here? What's the diff between elements and tags in HTML? And HTML tags and are this actual syntax used to define elements. They are the opening tag and closing tag markers that enclose the context. Example, the paragraph, the div, the header one. Elements include both the tag and the contents inside them. An element is the complete structure, including the opening, contents, and the closing tag. Okay, so open HTML tag, open head. So we'll say define or replace element with tag. Okay. So the tag is the individual syntax, right? The element refers to the actual entire, structure from tag to tag. Gotcha. +1 to Jippity. Can't get over script serpents. Yo, bro, what? I can just imagine him just being like, what? Yeah, he's switching the words. Web dev called them tags. Okay. Anything in here is a tag. Okay, great. Nice, Ryan. Thanks, Tim. Right back at you. Not me asking ChatGPT. Well, we we used like what 6 gallons of water to ask the same question there, Ryan. We're bad people. All right, let's keep going.
A new file. Actually, let me retract that. Let me open my terminal window, and instead of showing the log, let me create a second terminal window with the plus icon. So I'm still running the other one with the command, but I still have the ability to run commands now in my here prompt. For instance, I want to run a command, code paragraphs.html. Let's go ahead and create a more interesting web page with actual paragraphs of English or other type of text. To save myself some keystrokes, I'm going to be in the habit today of copying the hello world example as a starting point, perhaps, and then just changing it as needed. For instance, I'm going to change the title of this here page to paragraphs. And then in here, I'm going to type out some paragraphs of text. Now, what are those paragraphs? Well, I wanted to save some time. So in advance, I generated some Latin-like text here so I can copy paste 3 long paragraphs of Latin text, some lorem ipsum text here. Now, it doesn't matter what this means. It's sort of nonsensical words. But this is a web page that is going to have ultimately some paragraphs of text. Not English, but fake Latin. So let's go ahead and open this. Let me go back to my other tab. I do need to reload this tab because I've created a new file that this browser didn't know about before. There it is, paragraphs.html. Let me go ahead and click now, paragraphs.html. And there are my 3 paragraphs. Well, wait a minute. This is just like one big blob of a paragraph instead of the 3 paragraphs that I was promised. Well, why is that? Well, let me go back to my editor here, and you'll see that even if I hide my terminal here, even though I've got these blank lines, clearly the browser is just ignoring me. And this is because HTML is pretty pedantic. Like, it is designed to only do what you tell it to do. And so if you don't tell it explicitly, give me a new paragraph, it's just going to combine adjacent texts, as we've seen already. So how do I do this? It's actually pretty simple. Let me go into my body tag, and let me actually open a paragraph tag, or P for short. Now notice VS Code is trying to be helpful by automatically completing the rest of this thought by giving me both a start tag and an end tag. In this case, that's not really helpful because I already have the text that I want to put inside of this paragraph. So I'm going to go ahead and delete the close tag manually, and I'm going to move over here and close this myself. And just to be stylistically nice, I'm going to go ahead and indent that. Now down here, I'm going to do one more paragraph tag, P for short. I'm going to cut that out, and I'm going to paste this in here. And again, I'm fighting with the auto formatting because it is trying to understand what I intend, even though I'm going back and fixing this now. Let me fix that. Let me go down here. Let me go ahead and fix this now. Indent here, and voila. Now we've got 3 paragraph elements. And to be clear, an HTML element is generally everything between a start tag and an end tag. So
Where was he?
3 paragraph elements, P for short. Why is it only P? Well, the designers of the HTML language years ago decided, why write out paragraphs when open bracket P, close bracket suffices? So let's now go back to my other tab. If I now, I see nothing changed, but again, that's because I already received the virtual envelope in my browser that contained the previous version of that page. If I want to get a new copy of paragraphs.html, I need to reload this tab, and now I see the same text, but broken down into 3 separate paragraphs. So this is just to demonstrate the point that if you want something to happen, you really need to tell the browser to do exactly that. Well,
I missed the part where he said he got his live server. How did he do that? Or does he have it installed, or was it a command he used? How do you generate this text again? I missed that as well. He copied it in, didn't he? Give me this. Got it. Ooh. You don't have to close the paragraph with the slash. Oh, yeah, you do. Let's just copy this over. Let's just quickly Get some paragraphs here. There we go. Command HTTP server. Okay. Oh. Okay. Now what? How do we go to... Okay. Cool. Nice. Thank you so much, Faifu. Appreciate you. Oh, and Smoking Noir, you're awesome. Why is it worth learning HTML and CSS if building tools like Wix and Google Sites exist? Honestly, from my experience, I've actually used Squarespace or whatever, not in Google, those types of things. They're pretty like limiting and they're kind of like boring and generic. Yeah, they do like the basic kind of clean stuff. So yeah, I mean, there's honestly probably no issue or probably with it, in general, right? Like in terms of if you're making something small, but if you want to maybe like know what's going on and know what's going on under the hood, and I don't know. What do you guys think? Web devs out there, what do you guys think? You need to be in the folder first. Yeah, we went into the folder. It's so fun building it yourself. People are saying it's fun. Lorem hashtag, where the hashtag is the number of words. Okay. Let's try that. Let's do another paragraph here. No, is it all lowercase? Lorem. Oh. Is it this? No. Tab. Am I trolling? Uppercase? Oh, tab, you said. Shoot. Sorry. Ooh. Yeah, Richard, I got the live server one in my my VS Code here. We've got that one here. So I've done half of the Odin project, so I'm not like completely like dumb in terms of like the HTML. I know like a little bit. Like I've done half of the Odin project. I've done like some basic websites and such, but so I kind of know my way around slightly. But I am kind of taking this as like I'm completely new, just to try to kind of recoup it all that way again. Like I'm truly trying to break it down here. Yeah, Richard, we got that one. Thank you. That's awesome. It's a good extension for sure. Yeah, you go live and you climb through the directories. Yeah. Do they have that extension within here we can download too, probably? They might have it in here. Yeah, the Lorem tab's not working for me. Lorem 25 tab. Not working for me. I don't know what's going on. All right, let's keep it moving. Let's keep it pushing.
Introduce some other tags too. Let me go back to my editor here. Let me go ahead and open my terminal window, and let's create something called headings.html. Much like a book, much like an academic paper, you might have section headings, like the chapter and the section and the subsection and so forth. We can actually implement this with some HTML too. So let me kind of cut a corner here and copy and paste paragraphs.html into headings.html. Let me hide my terminal window. Let me change the title here just to be headings, to be super explicit as to what's going on. And let me go ahead now and say H1, 1. And down here, let me say H2, 2. And down here, let me say H3, 3. Now, Now, these are 3 new tags, H1, H2, and H3. By definition, H1 is typically big and bold. H2 is typically not quite as big, but still bold. H3 is not quite as big still, but still bold. And these are the default stylizations of these here tags that come with HTML. Let me go back to my other tab. Let me click back. So I now see my new file, headings.html. Let me click on headings.html. And now, even though it's still nonsensical Latin-like text, at least it's starting to look pretty. Looks like a chapter of a book with some sections and subsections and so forth. That's because the browser now understands what it is I want of it. Now, you could simulate this by just literally typing the word 1 in its own paragraph, the word 2 in its own paragraph, the word 3 in its own paragraph, but it wouldn't be bigger and it wouldn't be bolder. And when it comes to the semantics of web pages, it's probably useful to use tags, in this case, like H1, H2, H3, because it kind of indicates the relative importance of the text. Like this is the beginning of the text, this is maybe some finer detail, and then this is the finest detail. It might actually help search engines, or heck, even AI nowadays, understand that these are different sections in your text. And we'll soon see there's even other tags you can do to be even more helpful to the browser and search engines and AI. Well, how about something else? Let's move away from big blobs of nonsensical text, and let's do something with a chunk of nonsensical lists. Let me go into my terminal window, create a new file called list.html, and let me copy paste my hello code from earlier just to save some steps. And let me go ahead and rename the title to list in this case. And let's just have a list of 3 things: foo, bar, and baz. If you've never heard these words before, they're sort of go-to computer science words when you just want some random placeholders. They mean nothing per se. But foo, bar, and baz are go-to default words like X, Y, and Z for mathematicians. All right, this looks like a nice, pretty list. I've indented it, which looks great. But if I go back to my other tab, hit back, and I click on list.html, I think you probably know where this is going. Just like the paragraphs, we just get one big paragraph of foo, bar, baz. We don't get foo on one line, bar on the next line, baz on the third. Well, why is that? Well, just as before, the browser seems to be ignoring white space beyond single white spaces. In fact, I can try to be really explicit, like, please give me some breaks between these lines. But if I go back to my other tab, click reload, it just canonicalizes multiple spaces into a single space, for better or for worse. So if I really want a list, I need to tell the browser that I want a list. And one way I can do that is as follows. Let me delete that temporarily. Woo! And let me do UL for unordered list, which means I'm going to get a bulleted list with little circles next to each word. Let me then use an LI tag for list item and type foo inside of the first. Let me type another LI tag and bar for the next one, and then a third with baz. And again, VS Code is auto-completing, which is why I'm able to type the close tags so quickly. But I've got now foo, bar, and baz inside of LI tags, which in turn are inside of a UL tag. Now, let me go back to my other tab, click reload, and now we have a bulleted list of items, one at a time. Well, what if I want to number this list? Well, I could certainly just go in here and start manually writing 1 and 2 and 3. But you could imagine that getting a little annoying over time, because if you need to reorder the list or add things to it, like, it's just minorly annoying to have to maintain numbers for lists of things. Like, this is what software is good at. This is an easy fix, and you might guess where I'm going with this. If I want to move from an unordered list, which is just bullets by default, to an ordered list, which is numbered, I can change the UL to an OL in both places. So that my start tag and end tag still match. Here. I can go back to my other tab, click reload, and what's going to happen by default now is, I get 1 and 2 and 3. And long story short, there are actually techniques whereby you can change this behavior using attributes to not just be these Arabic numerals, but you can use Roman numerals or other symbols that browsers are designed to support. And it all just kind of happens for you, which is great, because if you're writing something like an outline for a paper or the like, you don't really want to have to think about all of those numbers, just like Google Docs and Microsoft Word. Like, the software should figure that out for you. And indeed, HTML can do just that. All right, how about one other here? This time, let me go ahead and cut a corner and open a file I created in advance just to save a few keystrokes. Let me close most of those files for now. Let me go ahead and copy from my source 8 directory a file I brought with me called table.html. And let me open this up in its own tab. And you'll see this file here that demonstrates a table. And indeed, I know that Because I have atop this file that I wrote in advance something called a comment. We've seen comments in C with //. We've seen comments in Python with hash symbols. In HTML, a little weirdly, you can write comments with open bracket, exclamation point, dash dash. Then you write your comment, and you finish your thought with another dash dash close bracket, but no additional exclamation point. Why these keystrokes? Well, the humans who designed this probably figured, who is ever going to type that sequence of keystrokes? Like, that's what we'll use for our comments tag. As an aside, if you ever actually want to write those patterns of characters, there's a way to escape those things, as we've seen in other languages as well. But let's focus on the juicy part here. What's inside the body of this here page? Apparently something called a table. And a table, by that we mean tabular data, like in a spreadsheet or in a database table. TR, I'll tell you, is short for table row, TR. TD, a little less obvious, but it's short for table data. So it's kind of like the cell in that row. And the fact that there are 3 table data elements inside of this one table row element means that there's going to be 3 cells, or really 3 columns from left to right, inside of this row. Below that is going to be another table row, inside of which are 3 more cells, 4, 5, 6, as their contents. Then 7, 8, 9. Then, curiously, an asterisk, a 0, and a pound symbol. So where are we going with this? Well, if you're imagining in your mind's eye a telephone that has buttons and labels, it seems like I've just been laying out rows and columns of numbers you'd see on your cell phone or an old-time landline phone. Well, let's still open this. Let me go back to my other tab, click back. Now you see table.html, and this isn't going to be all that pretty, but it is tabular data. And if I zoom in with Command+ here in my browser, you can see that this is laid out rather like a phone pad. Now, this is not a super compelling use, but you can imagine actual tabular data, maybe data that came from a database, maybe Google, in fact, when they implemented Google Sheets, or Microsoft when they implemented Office 365 in the cloud for Excel. Maybe that's how they're laying out all of your data in your browser as it is. Underneath the hood, they are using, of course, HTML, but specifically table tags like this. Now, as an aside, they're probably doing even fancier things than that nowadays, but they certainly could use TR tags, TD tags, and these table tags as well. All right, enough about text. Let me actually go back to VS Code here. Let's close table.html, and let's do something with an image. In fact, let me go ahead and grab a file called maybe bridge.png, which is a portable network graphic version of the bridge with which you're now familiar, that we ran a number of filters on in the past. And this is now in ping format because BMP format, which we used in a previous problem set, tends not to be used on the web or supported necessarily by browsers, but pings are, GIFs are, JPEGs are, and potentially a few other formats as well. So I'm pretty good going with portable network graphic. We're good to go. So let's create a web page that actually includes this image, because at the moment I'm just showing you the image. I'm not actually embedding this image in a web page like Google or other websites would. So let's do this. Let's close that tab. Let's open a new file called image.html. Just to save some keystrokes, let me copy paste my hello world example again, changing the title to image. And in the body of this page, instead of any text, let's actually put an image from Harvard University. Let me go ahead and use open bracket IMG for short. Source equals quote unquote bridge.png. So in this case, we have a couple of new things going on here. We've got a new tag, of course, IMG, which is short for image. Why? It was just faster to type for humans than image, so they called it 3 letters instead of 5. Source is representative of another attribute. We saw an attribute earlier, lang equals en. Well, it turns out that the image tag, if you read its documentation or listen to me now, has an attribute called source, src for short, that allows you to specify the source of an image that you want to display in the page. But somewhat differently here, the image tag that I've written has no close tag, no end tag. I could do this, but frankly, open bracket /image, but frankly, this seems a little unnecessary, if not confusing, and it is technologically unnecessary. It turns out that some tags can be empty in the sense that they don't need a close tag, and an image kind of makes sense, right? Unlike a head of the page, the title of a page, the body of a page that start over here and maybe end down here, an image is either there or it's not. Like, you can't start showing the image and eventually stop showing the image. Like, it's either there or it's not, so you don't really need an end tag for certain start tags. An image is among the examples. If now I go back to my table here and click back to see my directory index, there is not only my ping, but also my image.html page. And if I click on this, it's not all that different from looking at the image itself, but apparently this is a pretty high resolution photograph that we took. I haven't done anything to resize it. And so what I'm seeing is a web page inside of which is this entire image. So that's OK, but I'm going to need eventually some techniques for shrinking this down. And we'll come back to that in a little bit. CSS, another language, is going to be one of our solutions to that there problem. But of course, things can go wrong. For instance, suppose that I mistyped this and I wrote bridge without the E, and I go back to this page and reload. That's, of course, a typographical error. And I see this broken icon. And you might have seen this on the real web. Sometimes images are broken because it's essentially a 404 happening underneath the hood. And in fact, the image just cannot be found. So if I want to help the user with this for a number of reasons, I can actually do this. Let me add an alt attribute for alternative and say something like Harvard University. In other words, in the event this image can't be displayed, go ahead and at least show the user some explanatory text. Better still, if someone is blind or they are using a screen reader to help them hear what is on a web page that they otherwise can't see, the alt attribute's value can be spoken aloud to someone with a screen reader so they know exactly what the image is that everyone else can see, so they can still appreciate what the contents of this web page are. If I go back to my tab here, in this case, it's still a typographical error, but at least now people with and without screen readers can see what this image is supposed to be. And even if I fix the typographical error and reload the page, if someone can see the image, they now will. But if someone's using screen reader software, which for those unfamiliar is software that looks at a web page and tries to describe in English or some other human language what is on the web page, now we have helped that device be all the more accessible as well. So you might have 0 or 1, or now it seems 2 attributes on a given tag. All right, well, what else can we do in terms of media? Well, there's something else we can do here. And I'll just show you this one and let you play around with it online if you'd like. In my source 8 directory, I've actually got a video file called video.html as well as video.mp4. And if I open the former of those, you'll see a page I wrote in advance that shows another technique about HTML. At the end of the day, we still only have tags and attributes. So like fundamentally, we've not really pushed ourselves too far here. But notice that there's a video tag in HTML that does come with 2 attributes at least, one called controls, one called muted. The controls attribute just means please show the user like a play button.
Sorry, I'm missing stuff.
What can we do in terms of media? Well, there's something else we can do here, and I'll just on a given tag. All right, well, what else can we do in terms of media? Well, there's something else we can do here, and I'll just show you this.
I'm lagging behind. I'm not getting my alt text to show up. He has it out front. Do you need it out front? What? What is the Odin project in a nutshell? It's just a, honestly, it's similar to this, but it's just a text guide. This is a text-based walkthrough of HTML, CSS, JavaScript, and GitHub. It's all just text pretty much, and it links you to videos and articles and things. It just kind of uses others' resources to teach the topic basically. Why am I not getting my alt text here to show up like he is? Right, he changed the.
We have helped that device be all the more accessible as well. So you might have 0 or 1, or now it seems 2 attributes on a given tag. All right, well, what else can we do in terms of media? Well, there's something else we can do here, and I'll just show you this one and let you play around with it online if you'd like. In my source 8 directory, I've actually got a video file called video.html as well as video.mp4. And if I open the former here, what's inside that? Because BMP format necessarily a few other. Let's create a wood and changing the title. In this case, we have a couple of new things going on here. We've got a new tag, of course, IMG earlier, or open bracket / image. But frankly, this seems a little unnecessary, if not confusing, and it is technologically unnecessary. It turns out that some tags can be empty in the sense that they don't need a close tag, and an image kind of makes sense, right? Unlike a head of the page, the title of a page, the body of a page that start over here and maybe end down here, an image is either there or it's not. Like, you can't start showing the image and eventually stop showing the image. Like, it's either there or it's not, so you don't really need an end tag for certain start tags. An image is among the examples. If now I go back to my table here and click back to see my directory index, there is not only my ping, but also my image.html page. And if I click on this, it's not all that different from looking at the image itself, but apparently this is a pretty high resolution photograph that we took. I haven't done anything to resize it. And so what I'm seeing is a web page inside of which is this entire image. So that's OK, but I'm going to need eventually some techniques for shrinking this down. And we'll come back to that in a little bit. CSS, another language, is going to be one of our solutions to that there problem. But of course, things can go wrong. For instance, suppose that I mistyped this and I wrote bridge without the E, and I go back to this page and reload. That's, of course, a typographical error. And I see this broken icon. And you might have seen this on the real web. Sometimes images are broken because it's essentially a 404 happening underneath the hood. And in fact, the image just cannot be found. So if I want to help the user with this for a number of reasons, I can actually do this. Let me add an alt attribute for alternative and say something like Harvard University. In other words, in the event this image can't be displayed, go ahead and at least show the user some explanatory text. Better still, if someone is blind or they are using a screen reader to help them hear what is on a web page that they otherwise can't see, the alt attribute's value can be spoken aloud to someone with a screen reader so they know exactly what the image is that everyone else can see, so they can still appreciate what the contents of this web page are. If I go back to my tab here, in this case, it's still a typographical error, but at least now people with and without screen readers can see what this image is supposed to be. And even if I fix the typographical error and reload the page, if someone can see the image, they now will. But if someone's using screen reader software, which for those unfamiliar is software that looks at a web page and tries to describe in English or some other human language what is on the web page, now we have helped that device be all the more accessible as well. So you might have 0 or 1, or now it seems 2 attributes on a given tag. All right, well, what else can we do in terms of media? Well, there's something else we can do here. And I'll just show you this one and let you play around with it online if you'd like. In my source8 directory, I've actually got a video file called video.html as well as video.mp4. And if I open the former of those, you'll see a page I wrote in advance that shows another technique about HTML. At the end of the day, we still only have tags and attributes. So like fundamentally, we've not really pushed ourselves too far here. But notice that there's a video tag in HTML that does come with 2 attributes at least, one called controls, one called muted. The controls attribute just means please show the user like a play button and a pause button and maybe some other things. The muted attribute means literally that, mute the audio by default. And that tends to be a good thing because nowadays browsers are pretty defensive against advertisements and annoying advertisements like videos auto-playing on websites. So you can ensure that your video will still auto-play, but without bothering the user. So you can mute the volume at least by default. But what's worth noting for our purposes is that some attributes apparently don't even need values. There's no equal sign, there's no quotes, which in some cases are necessary to specify the language of this page is in English, but some attributes indeed do not need values. And even if they do, you can use, as in Python, single quotes or double quotes, and sometimes no quotes at all. But I would get into the habit still stylistically of using double quotes for consistency, as I have. But as for the rest of this, a source tag exists, which you can put inside of the video tag. It itself has, confusingly, a source attribute, SRC for short, as well as a type attribute, which indicates what type of video are you trying to play for the user. So I'll wave my hands at some of that media, but you're welcome to play that page and open it on your own and even unmute it to see what I've otherwise shown. But let's now make the web all the more interactive. Let me close that example. Let me go ahead and open a new file called link.html and start making that example what I've otherwise shown.
Chill, bro.
But let's now make the web all the more interactive.
Chill. People are trying to type here. Jeez. This one's taking a little while. Okay.
Let me close that example. Let me go ahead and open a new file called link.html and start making the hyperlinks with which we're all familiar. Clickable links in web pages, which is what makes the web itself. Let me cut some corners here and copy paste my hello world example into link.html. Let me change the title to link just so we know what's what. And let's actually make a page that has a genuine link to Harvard's, to maybe that image of Harvard called image.html. I could say something like this. Visit Harvard, period. Now, this, of course, is just text, so this is not that interesting. But just to make sure we're on the same page, let me click back. Let me go to link.html. And you'll see that I've called it link.html, but there's no link there. I can click Harvard all I want, but nothing actually happens. So let's make it a link. What do I want to link to? Well, I could link to Harvard's website, but I already have a picture of Harvard. Let's try linking to a page relative to this one. Let me go ahead and open a new tag called the anchor tag, A for short. Let me use its attribute called href, which is a little arcane, but it stands for hyperreference, the destination of this link. Let me add some quotes and say image.html, close quote, close tag. And then notice VS Code's trying to be helpful, but sometimes it doesn't know what I intend. So I'm going to delete the end tag, move my cursor over, and paste it at the end and finish my period there, just because I want everything to be balanced. And now, even though this one looks a little more cryptic, this is now the beginning of hyperlinking pages on websites. If I go back to my other tab, click reload, now I see the familiar underlined text, which of course signals in many web pages that this here is a link. If I hover over it, it's going to be a little small, but in the bottom left-hand corner of my browser, which is Chrome, I can actually see that this will lead me to a page called image.html. And indeed, if I click on Harvard for real, I get back to image.html. And the URL in my browser has changed from link.html to image.html. So this is what's known as a relative link, whereby I'm linking from one of my own pages to another of my pages. They're in the same folder, so I don't need to mention any folder names. The server just knows what I want. So that's then a link. But what if I want to link to an actual URL and not just a relative page like Harvard's own website? Well, that I can do too. I can change the value of this href attribute, and I could just do harvard.edu. Unfortunately, this is not going to work. The values of hrefs in a web page, if they're going to be full-fledged URLs, have to be actual URLs, protocol and all in this case. And so I'm going to do https://www.harvard.edu. And heck, I'm going to include the trailing slash, even though I don't strictly need it. And technically speaking, I could omit the protocol if I want the same protocol to be used. But in general, I'm going to link to the full-fledged URL of harvard.edu here. I'm going to go over to my image tab. I'm going to kick back to go back to my link tab. I'm going to reload to make sure I get the latest HTML in my browser. And if I hover over this now, super subtle, but in the bottom corner of my browser now, this indeed leads me to harvard.edu. And if I click that, we should see the familiar forests that we saw a little bit ago. And now this is an external link, not a relative link, that I've now implemented in this web page. All right, let me click back. And let me reveal one other feature now of those so-called developer tools. Previously, I opened up developer tools when I wanted to play around with HTTP, the protocol that just gets the web pages from browser to server and back. But now, it turns out I'm going to use another feature of my developer tools by right-clicking or control-clicking anywhere on my page or going through the main menu. I'm going to click Inspect. And now Inspect makes a little more sense because now I'm literally inspecting the web page itself. Notice at left here is a visualization of the underlying HTML of this web page. And some of it's hidden, but I'm going to click the little triangles to reveal the rest of it. And you will see essentially at left here under the Elements tab in Chrome a list of all of the elements that compose this web page. And again, an element is everything between an open tag and a close tag. So in this case, I am seeing a very pretty printed version of my own source code. And some things are broken out onto different lines just to make clear that here's some text, here's a link, here's some other text, both of which are inside of this body tag. And notice too, as I hover over things, Chrome, just to be helpful, because if I'm a developer, I want some help here, I can see in light blue what I am hovering over in my HTML being mirrored in the actual body of the page. If I hover over the body, I see everything to the body as well. Now, what I can take away from this is the following. This here is my web page, and it's very pretty printed. If I close this tab, I can see my same code in another way. If I right-click or control-click, I can also go to View Page Source. View Page Source is a feature that's been in browsers for years, and you can see the same code, but exactly as it came from the server. I happen to be pretty nitpicky, so it's all nicely indented as well. But this is a static version of the page, whereas the developer tools allows me to actually poke around with things. In fact, let me close this tab. Let me re-click again on Inspect. And watch this. If I want to poke around here, I could actually go into the developer tools and temporarily, without even going back to my terminal window, I can click on or double click on anything in this page, and I can actually change it in real time. Like I can change Harvard to Harvard University and then hit Command Enter. And in this case, I can change the contents of the web page. But curiously, that has not changed anything on the server, because this makes clear the point that once the browser has requested a web page from the server and downloaded that virtual envelope inside of which is the original version of link.html, that's what the browser is going to keep in its memory. You can change your copy of that page all you want, but it doesn't affect the server at all. The browser gets a copy of what's on the server. In fact, we can take this feature out for a spin, seemingly maliciously, but not in a way that has any effect. In fact, let me pull up not just harvard.edu, but specifically the admissions page for Harvard College, and scroll down here, and you'll see this advertisement toward the end, why Harvard? Well, notice that if I want to see the underlying HTML of this page, I can see it in a couple of ways. I can right-click and choose View Page Source, and it's going to look like way more code than we've written to date. This is me scrolling through all of the HTML that composes the admissions website's HTML at Harvard. There's a lot there, but it's going to follow that same pattern of tags and attributes. Or I can kind of pretty print it by going to Inspect, going to the Elements tab, and there, notice, is the exact same content, even though I was scrolling through it super fast, but it shows you everything pretty printed, so you can kind of poke around. More importantly, I can click on any part of the page with my Control key or 2 fingers and select Inspect. And what's nice is that Chrome, and really any browser, will jump to the specific HTML in the browser's memory that corresponds to that part of the page. The upside of this is I can actually infer, how did Harvard make this web page? How did they structure their HTML? Now, we haven't talked about all of these tags yet, but notice that there's all of these div tags, div, there's a section tag, but there are some familiar ones. Here's an h2. Harvard is using an h2 tag for why Harvard. Here's a ul down below for some kind of unordered list. But notice here I can be a little playful here, and maybe we should nudge people to go to Yale instead. Let me change in the Elements tab, Harvard to Yale, hit Enter, and now I seem to have hacked Harvard's website, and it suddenly says why Yale instead. But of course, this changes nothing on the server because this too is a copy. And the moment I reload Harvard's website, I get a fresh copy of what's actually on the server. So what's the value here? Well, one, pedagogically, it's just a useful mechanism, these developer tools, for understanding and learning how a website is structured if you want to do something similar yourself. As a developer tool, frankly, sometimes it's a lot faster to just mock things up in the developer tools, decide, OK, I like how this looks, and then go over to your actual HTML and make the changes for real. It's a faster way of iterating, and it's also a helpful way of diagnosing certain problems that we might otherwise run into. All right, but there's still a danger here. Speaking of Harvard and speaking of Yale, let me go ahead and close that tab there and return to the HTML of link.html. It turns out that the attacks with which you're familiar in the real world, namely phishing attacks, are all too easily waged via HTML alone. To be phished typically means to receive some kind of spam email that's trying to trick you into clicking on a link that purports to be legitimate, but is really taking you to some adversary, some bad guy's website that's trying to steal your credit card information, your username, your password, or something like that. And those emails in Gmail, in Outlook, and other tools, they themselves are using HTML. Anytime you get an email that's not just black and white text, but has colors and maybe images and formatting, it's using HTML. So HTML is used not only for web pages, not only for mobile apps, but also for link that I've now makes a little more.
I'm sorry, guys. I kind of missed all of this stuff. I was on Safari, so I just kind of said, all right, let's just go on Chrome, what he's on, and let's just use Chrome. So I kind of want to go back and see what he had to say about this, because I don't want to really miss anything. Especially when it comes to this inspect stuff, because this stuff's pretty important. I see a lot of web developers on streams and stuff, always using and referencing this inspect and element stuff. So need to get familiar with that.
Sense, because now I'm literally inspecting the web page itself. Notice at left here is a visualization of the underlying HTML of this web page. And some of it's hidden, but I'm going to click the little triangles to reveal the rest of it. And you will see essentially at left here under the Elements tab in Chrome a list of all of the elements that compose this web page. And again, an element is everything between an open tag and a closed tag. So in this case, I am seeing a very pretty printed version of my own source code. And some things are broken out onto different lines just to make clear that here's some text, here's a link, here's some other text, both of which are inside of this body tag. And notice too, as I hover over things, Chrome, just to be helpful, because if I'm a developer, I want some help here, I can see in light blue what I am hovering over in my HTML being mirrored in the actual body of the page. If I hover over the body, I see everything to the body as well. Now, what I can
really
take
useful.
away from this is the following. This here is my web page, and it's very pretty printed. If I close this tab, I can see my same code in another way. If I right-click or control-click, I can also go to View Page Source. View Page Source is a feature that's been in browsers for years, and you can see the same code, but exactly as it came from the server. I happen to be pretty nitpicky, so it's all nicely indented as well. But this is a static version of the page, whereas the developer tools allows me to actually poke around with things. In fact, let me close this tab. Let me re-click again on Inspect, and watch this. If I want to poke around here, I could actually go into the developer tools and temporarily, without even going back to my terminal window, I can click on or double click on anything in this page, and I can actually change it in real time. Like I can change Harvard to Harvard University and then hit Command Enter. And in this case, I can change the contents of the web page. But curiously, that has not changed anything on the server, because this makes clear the point that once the browser has requested a web page from the server and downloaded that virtual envelope inside of which is the original version of link.html, that's what the browser is going to keep in its memory. You can change your copy of that page all you want, but it doesn't affect the server at all. The browser gets a copy of what's on the server. In fact, we can take this feature out for a spin, seemingly maliciously, but not in a way that has any effect. In fact, let me pull up not just harvard.edu, but specifically the admissions page for Harvard College, and scroll down here, and you'll see this advertisement toward the end, why Harvard? Well, notice that if I want to see the underlying HTML of this page, I can see it in a couple of ways. I can right-click and choose View Page Source, and it's going to look like way more code than we've written to date. This is me scrolling through all of the HTML that composes the admissions website's HTML at Harvard. There's a lot there, but it's going to follow that same pattern of tags and attributes. Or I can kind of pretty print it by going to Inspect, going to the Elements tab, and there, notice, is the exact same content, even though I was scrolling through it super fast, but it shows you everything pretty printed, so you can kind of poke around. More importantly, I can click on any part of the page with my Control key or 2 fingers and select Inspect. And what's nice is that Chrome, and really any browser, will jump to the specific HTML in the browser's memory that corresponds to that part of the page. The upside of this is I can actually infer, how did Harvard make this web page? How did they structure their HTML? Now, we haven't talked about all of these tags yet, but notice that there's all of these div tags, div, there's a section tag, but there are some familiar ones. Here's an h2. Harvard is using an h2 tag for why Harvard. Here's a ul down below for some kind of unordered list. But notice here I can be a little playful here, and maybe we should nudge people to go to Yale instead. Let me change in the Elements tab, Harvard to Yale, hit Enter, and now I seem to have hacked Harvard's website, and it suddenly says why Yale instead. But of course, this changes nothing on the server because this too is a copy. And the moment I reload Harvard's website, I get a fresh copy of what's actually on the server. So what's the value here? Well, one, pedagogically, it's just a useful mechanism, these developer tools, for understanding and learning how a website is structured if you want to do something similar yourself. As a developer tool, frankly, sometimes it's a lot faster to just mock things up in the developer tools, decide, OK, I like how this looks, and then go over to your actual HTML and make the changes for real. It's a faster way of iterating, and it's also a helpful way of diagnosing certain problems that we might otherwise run into.
Cool.
All right, but there's still a danger here. Speaking of Harvard and speaking of Yale, let me go ahead and close that tab there and return to the HTML of link.html. It turns out that the attacks with which you're familiar in the real world, namely phishing attacks, are all too easily waged via HTML alone. To be phished typically means to receive some kind of spam email that's trying to trick you into clicking on a link that purports to be legitimate, but is really taking you to some adversary, some bad guy's website that's trying to steal your credit card information, your username, your password, or something like that. And those emails in Gmail, in Outlook, and other tools, they themselves are using HTML. Anytime you get an email that's not just black and white text, but has colors and maybe images and formatting, it's using HTML. So HTML is used not only for web pages, not only for mobile apps, but also for emails as well. And here's how easy it is to unfortunately deceive users. Suppose that I still have a link here to Harvard, but I actually changed the actual href to be yale.edu. If I go back to my actual browser here and close my developer tools and click reload, the page still says, like the HTML, visit Harvard, period.
Yeah, you can.
And this is super subtle, but if I hover over this link in the bottom corner of my browser now, I'm actually going to be led to yale.edu if I click this link. In fact, if I actually do that, voila, now I'm actually at yale.edu. So not a big deal in this case. I'm just sending one student from one place to another. But you could imagine making a website that looks like a bank's website, that looks like PayPal's website, that looks like something legitimate, such that when I click on a link, no one's really looking in the bottom left-hand corner of their browser all the time. You could all too easily trick a user into visiting a page and maybe filling out a form on a page that they didn't actually intend. And we say this not to empower you to do such things, but the opposite, to detect when such behavior is happening. And frankly, getting into the habit of hovering over links that you're a little suspicious about is probably a good practice. But for today, know just how easily these threats can be waged and why there are so many of these threats to us online. It boils down to these basic fundamentals. Now, all that said, we haven't even done anything dynamically. Every web page we've made thus far has still been very static, like content I have made in advance, and you can reload all you want. It's always going to look the same from the server again and again. But how about we revisit how URLs work, not just to serve up static content, but dynamic content as well. It turns out that besides having folder names and file names at the end of URLs, you can also have a question mark in URLs, and then key value pairs, literally with an equal sign in between them. We've seen key value pairs all over the place, most recently in things like dictionaries, for instance. But in this case here, we have a canonical format for how you can actually provide input from a browser to a server, typically that's typed in via a form. So for instance, let me actually open up a brand new tab here. Let me go to google.com, just the main page that doesn't come with my browser. And I'm going to go ahead and type in something like cats, C-A-T. Now, ignoring the fact that there's a whole lot of autocomplete going on here, let me hit enter. And let me emphasize what my URL. We can be distracted for a moment by the cute cats on the top of the page. But let's then zoom in on the top of the page here, where we'll see a very long URL, most of which, frankly, I don't understand, and probably only Google employees would understand what everything is in this URL. But let me delete most everything except the essence of this URL. And what I've left at the top of my browser is only https://www.google.com/search, which is the path, Q equals cats. It turns out, way back in 1999, when Larry and Sergey founded Google and created their very first search page, they had a text box just like this one, but more simple in design. And if you filled out that text box with one or more words and hit enter, you submitted a query to the server for which you want to search, Q for short. And so all that form needs to do when you hit enter is change the URL, it would seem, to take that user input in a standard format. Q equals cats. Something equals something. Something equals something. In fact, if there's multiple such parameters, as these are called, just like in functions, you can separate them with ampersands. But the question mark just means to the server, hey server, here come some key value pairs, otherwise known as HTTP parameters. When I hit enter, the search results are actually going to be exactly the same. Most of the other stuff in the URL is probably for tracking purposes, so Google can keep track of what I'm searching for and what I'm clicking on. But in essence, if we distill the URL to just question mark Q equals cats after search, we have provided user input to this here page. And what's cool about that is the following. Normally, the canonical URL might be as simple as this, or it might actually have two key values in pairs, which indeed can be separated by these here ampersands. I think I can take advantage of this here feature and implement like my own version of Google. Let me do this. That's kind of it for HTML. Like there's bunches of other tags and attributes out there, but those are really for an online tutorial or book or reference or some other source to just pick up what more vocabulary there is. At the end of the day, it's just more tags and more attributes following this shared structure. So for now, I want to make things more dynamic, leveraging my knowledge of just that. Let me go back into my VS Code. Let me create my own page called search.html, enter. Let me save a few keystrokes by copying and pasting my hello world code and changing the title to search. Let me get rid of the body here. And let me begin to create my very own form using literally a form tag, F-O-R-M, space, and then here I'm going to close the tag immediately. Inside of this form element now, let me go ahead and create an input whose name equals Q. And inside of this form element, let me additionally add an input whose type equals submit. And we'll see what this gets us first. Let me go back to my other tab, click back to see my directory listing of files, click on search.html, and this is super simple, but I seem to have the beginnings of an interactive web form, a big text box and a submit button by default that seems to be a form. Unfortunately, if I type big type equals and in my very own form using literally a form tag, F-O-R-M, space, and then here I'm going to close the tag immediately. Inside of this form element now, let me go ahead and create an input whose name equals Q. And inside of this form element, let me additionally add an input whose type equals submit. And we'll see what this gets us first. Let me go back to my other tab, click back to see my directory listing of files, click on search.html, and this is super simple, but I seem to have the beginnings of an interactive web form, a big text box and a submit button by default that seems to be a form. Unfortunately, if I type in anything to this, cats, and then click submit, nothing actually happens. But if I go to my own URL here at the top, notice that I'm still on search.html, but $Q equals cats was automatically added for me by the browser as soon as I click submit. So let me go back and add a little more detail in my editable file. Let me specifically specify that the type of this text box is text, but that it turns out is the default. So I'm actually going to enhance that and make this a search box specifically. Let me go back to my browser and reload. And this is subtle, but if I now type in cats, notice that I get this little X here, which is just a user-friendly feature, which means now I can click on the X to clear that box. That is simply because I changed the type of this box from generic text to a search box, for which that feature is useful. I don't really like the idea of submit. I'd kind of like my button to say something about Google. So let me go back to my submit tag here and change the value of that input to be quote unquote Google search. Then let me go back to the page, reload, and now things are getting a little more interesting whereby I have a Google search button. It still doesn't do anything.
We're making buttons.
But let me be more specific. When I submit this form, I want the method to be used, the verb to be quote unquote get. Somewhat confusingly, the convention is to use lowercase here, even though inside of the envelope I've demonstrated with curl that it tends to be capitalized in the actual HTTP protocol. But so be it. But get is actually the default, so I don't strictly need that. But what I do want to add here is an action. What action do I want this form to take when submitted? Well, I don't have a backend. I don't have a database. I have not searched the web ever with this here code space, but Google has. So let me use Google's backend, their servers and database, to search for whatever Q is. Let me change the action value here to be https://www.google.com/search. So just the beginning of that URL without the question mark. Now let me go back to my search tab, reload, and now nothing visually seems to have happened, but if I type in cats now and click on this new and improved Google search
No,
line,
we made
watch
Google.
what happens not only
We
to
made
my
Google.
URL, but the contents of the page.
We
I
made
have
Google.
just searched
Woo!
for my own web page for cats on google.com. In other words, by nature of how HTML
So am I an engineer now? Am I a Google engineer? Am I need code?
forms work, specifically using the get method, and the action of Google's own URL, my browser knows how to assemble all of those ingredients into a brand new URL that contains as the value of Q whatever I typed into that box. And heck, I can do this manually now, even though no one searches like this. I could just search for Q equals dogs, and now I get some adorable dogs as my search results here. But that's just because I now understand what these URLs are doing for me and how they are structured. If I zoom out and I go back to search.html, I can actually make some improvements here to that same form. You might have noticed that when I typed cats the second time, I actually saw it auto-completing as cats. There was a little popover there. If I don't want any autocomplete, there's an attribute for that. Autocomplete equals quote-unquote off. This will now disable the browser from remembering things that I've searched for before. I can also do this. Notice if I go back here to my search page and click reload, notice that with no hands on the keyboard, the box is there, the button is there, but my cursor isn't. I have to manually focus my cursor on that box, and then it gets highlighted in blue and I see the blinking cursor. That's not the best user experience, or UX, so to speak. Why you're going to make the user move their cursor and put the cursor where you want it to be anyway. So I can fix that. Let me go back to this same search box and let me add autofocus. And I don't actually need to give it a value, but if I now go back to the page and reload, watch, even without clicking on that text box, it's already highlighted and blinking because I've given focus, so to speak, to that there text box. Now, what is this text box? It's just a big white box. Well, if you read the documentation for, or listen to what I'm here saying about the input tag, you can also have a placeholder attribute that can contain any text you want, like query, for instance, quote unquote. If I now go back to this page, reload once more, now you see in gray text inside of the box sort of explanatory instructions as to what I'm looking for. And as soon as I start typing CATS, query, goes away. So that too is a feature you've probably seen in browsers that's just the result of someone having used the right HTML tags and attributes. Now, I've been a little deliberate here. I have alphabetized all of my attributes, if only because it helps me personally skim things from left to right and know if I've missed something that I intended. But strictly speaking, there's no official ordering to any of these attributes. You can put them left to right, right to left. They don't need to be alphabetically sorted. But stylistically, this is indeed what I myself tend to do here. Let's take a look at one more use of forms that will allow us to introduce another feature that's present not only in HTML, but in other programming languages as well, including, in fact, Python. So let me go ahead and create a new file here called register.html. And let's just imagine that we're trying to create a web page via which someone can register for something, a website, a sport, or anything else. And what I'm going to do in register.html is save a few keystrokes and copy my search code into register.html, and I'm going to change the title to register, and I'm going to get rid of the form as a starting point here. Let me close my terminal, and inside of this form, let's just create the beginnings of a registration form. But unlike the Google example, I'm not going to bother trying to submit this anywhere. That'll be a goal for another time. But let me go ahead and in this form create an input. For which autocomplete is off, like before, for which the field is auto-focused. And you should only have one autofocus field, otherwise the cursor doesn't know where to go. Let me specify that I want this input to be someone's email address, because after all, I want this to be a registration page. So the placeholder text I'm going to be using is email, so they know what to type. And then the type of this field, for now, is just going to be text. And then I'm going to go ahead and have a submit button. But it turns out you can have different types of buttons. And one other way to express a submit button is literally with an HTML element called button, for which the label here will be register. So long story short, there's different ways to implement buttons. Here is now a second way. Let me now go back to my other tabs. Let's close the tabs. Let's hit back to get to my directory index. And let's now click on register.html. So very similar in spirit to my search form, but now I'm clearly asking for an email with a registration button. However, I could try to register with anything here. In fact, if I'm not paying attention, maybe I'll just type my name like I always do in these examples and click register. And even though nothing technically happened, notice my URL did change. So the form was submitted because email equals David is appearing there. But that was not an email address. And it would be nice if the browser says, no, 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 that's not an email address. You cannot submit that form yet. But if this is just a text box, it's going to tolerate any kind of text. But as you might know from Microsoft Office and Google Forms, you can certainly validate forms in those kinds of software. Certainly, we could do so in HTML. Well, we can in a couple of ways. Let me go back to my HTML, and let me change the type of this input to be not text, not search, but email. And it turns out that this is one of the officially supported types of inputs nowadays, where the browser will now know that, OK, before I can let the human submit this form, I better check that they're typed in an email. So let me reload this page. Let me again foolishly try to type in just my name, not my email, and click register. And now notice I'm getting admonished by the browser. This is a default pop-up that's saying, please include an @ in the email address. David is missing an @. So obviously, I've not typed an email address, so let me fix this. mailin@harvard.edu. Now the error has gone away. I can click register. And even though nothing useful happens, again, the URL changed, indicating that I did submit the form, just to know we're useful. All right, so that's all fine and good. But it turns out that email is one of the relatively few types of fields that you can check for, in addition to search and text more generally, and a few others as well. But it turns out that browsers nowadays, in the context of HTML, support what are called regular expressions to help.
All right, that is where we will pause the lecture watch for today. We will watch the second half, getting into regular expressions, CSS, and JavaScript tomorrow. So make sure you come back tomorrow for the lecture watch along tomorrow. But that's going to do it for the watch along for today. This is a great. I want to just quickly go back slightly and get the code regarding that email regular expression thing. So type equals email. Or type equals text. Yeah. Okay, like that. So now if we go here, refresh, you have to provide an email. Okay, gotcha. I have regular expression PTSD. I was pretty good at regular expression in the Python for Harvard CS50 Python. I don't know. I just really liked that week. I picked it up quite nicely using the little codes to understand placeholders. It really kind of just like clicked right away. Now I don't remember a ton. I could go back and kind of reference my notes regarding that. But I do remember the gist of it, using those symbols to represent various kind of codes for user input detection and, limiting the user input based upon those codes. I started about 6 months ago. Or when do you start? 7 p.m. every single day. Around then, if my work allows it for it. So those that don't know, my name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry. Graduated from college back in 2021 with that degree. I work as a formulation chemist for a biotech company where I got a job right out of college 3 years ago. When I graduated, I've been there. I'm a scientist too, a mid-level scientist. I've received a couple of promotions along the way, and I've been teaching myself how to program for about 6 months now. We started with Harvard CS50P. We quickly solidified that knowledge and learning with some examples in Work in Python Crash Course, where I started the channel and got some great practice and read this book entirely live on stream. That's what really launched and kickstarted this channel. And then we are reading right now the data structures and algorithms in Python. And then let me quit out of that real quick. We are reading the data structures and algorithms in Python currently, right here, as you guys can see. We're currently on page 437 out of 770. And so we're over halfway done with this book, completely live reading on stream. It is pretty dense and difficult to understand at times, but we're doing our best to break it down and get a kind of a first introduction and understanding of these data structures that are pretty key in this industry now. And then we are getting further knowledge in these courses and practice with them. And so this is kind of our first pass and a breakdown and really trying to translate what's going on. And yeah, it can be difficult, but it has been shown to be useful for these courses I didn't have any problems in the CS50X week about time complexity and algorithms and data structures. I flew through those weeks really understanding what was going on, and it was pretty useful. So yeah, just got done getting how understand SML, SF was lacking. Awesome, dude. Nice. All right, so this was a lot of information. We got a lot of practice with HTML. I really tried my best not to copy and paste the boilerplate because I wanted to get practice writing it out myself and understanding. And because I think what's going to be really difficult about this, in all honesty, is remembering all of these various, I don't know, methods or functions or attributes or whatnot, uh, uh, or parameters basically, and kind of remembering everything. It's a whole like language within itself in that it like it's just a whole new ball game of um, like a whole library almost. It was what it seems like. So, but it doesn't seem too difficult. It kind of is the general key like lines of markdown and things like that, or just basic formatting. But obviously, just understanding and knowing all of the available tools to us is going to be the issue, and then we got to go into styling and functionality and stuff like that. Just use the MDN docs if you forgot something. What is the MDN docs? I've never heard that acronym before. But I can definitely feel myself like, the quickest thing that's going to start to go is like all these little, autofocus, placeholder, all these little type, like all these little things. I don't know. How do you guys remember them? The important thing is getting the gist of what can be done and what exists. Okay, yeah, I think maybe I get caught up, and maybe some other people also get caught up too much on trying to remember everything and make sure they remember everything, when in reality it's mainly understanding the key concepts and backbones maybe, and then if you can always go back and reference something, right? There's always going to be reference, but if you don't actually know what you're referencing, then that's where the problem lies potentially. All right. That was a fun one. I've got a lot of big plans for the stream, you guys. I really enjoy you guys coming with me every single day and learning. I want to make this more interactive, more fun. Once we get through the Harvard CS50X course and I have a little bit more knowledge of, some front end development and stuff, we're gonna maybe develop, some front end projects. Maybe also apply like a front end element to our small business manager. I think would be really cool and useful to intertwine those two. We already have a whole back end, system for managing the file IO and interacting with the input from users and stuff. And so if we can just accept that somehow through some sort of online forum basically that we create, I think that would be really useful as well. What do you guys think about that? Is that something that you guys think would be possible? um, Also, I want to make it more interactive in the terms of I want to maybe open that up once we get to that point for um, you know uh, uh, like an open source project. So it'll be like I'll launch 1.0, which is just the CLI environment that I personally made, and then together we can create a 2.0, which will be web, and whether we do a server-based database or something, I'm not sure. We can go and learn all that, and we can learn it together, and really AJ, Richard, we can all come together, Mahan, everybody, Script Serpent, Phi Fu, Wing Hong, SS Low, Tim, yeah, our chorism, everybody, we can come and work on this together, and then maybe we could all jump in a Discord call on like live on stream one day and like work on it together, and create like work sessions or something, and it'd be really cool. It is what we make it, but also I want to make it more fun and then learn time and something more coding related. Is like I said before, is I want to do like halfway every hour of the stream we open up like a pack of Pokemon cards. So every hour that we stream, or every hour and a half, we'll do a pack opening, and then we'll save the cards for the week or every 2 weeks, and then we'll give them away to everybody, just to say thank you guys for being here and spending time with me and supporting me, and working on your education as well as helping me out with mine. So thank you guys so much for joining me tonight. I'm gonna wrap it up here. We streamed for 2.5 hours. Well, should we wrap it up here? It's getting kind of late, and I streamed really late last night, so I do need to get a little bit of better night's sleep tonight. I've been getting only like 5 to 6 hours every single day, and maximum 7. And I mean, 7's not too bad, but 5 and 6 for the amount of work we're doing, I definitely need to be better at keeping up on my sleep. But oftentimes when I get off the stream, I'll take my computer out while I watch some show, and then I'll just be like coding or editing videos. I'm still working off stream. I got more stuff to do. Mozilla documentation. It is HTML, CSS, and JavaScript documentation. Okay. For HTML, remembering all the tag names is so much easier than Python or JavaScript or anything. I think you'll agree in time. Okay. I had that same feeling with Python. So I will take your word for it, because when I was first learning Python, I had that same question of, how am I going to remember all of this stuff? Like, it's just, sort versus sorted function versus dot reverse, but you can insert a reverse parameter into the sorted function. So it's just like, how am I going to remember all these little like things? But then as I started practicing with them, and then it just became kind of like muscle memory. Like, I just started doing it over and over and over again, and then little you know, you just kind of talk. You just becomes just how you talk, I guess, like fluency. Styling is the easiest programming language to use. You're only on day one. Yeah, in my opinion. I'm willing to help you with your front end UI if you desire it. I can send you my projects well. You can see. Awesome. Yeah, for sure. I mean, it's going to be like an open source, or I want it to be, everyone's point of view and perspectives, and we can all create like a fun little. We can like maybe delegate out certain assignments, and um, you know, make a cool project. If we have 20 or so people working on it, we can get something cool done quite fast. I think. I see a lot of people on Reddit, on like the CS majors, and on the learn programming things, just saying like, oh, I can't find a job, we're screwed, yeah, it sucks along those lines. And I often think, I wonder, like, what would be like the strength of, there's tons of these people with tons of knowledge that are just trying to work for somebody else. Why not just, come together and, at least attempt to, do something together? You have all of these skills, hundreds of people sitting there kind of just complaining about their experiences, and their hardships, which, yeah, are very valid, because they're hardworking, and probably very knowledgeable and stuff. But they have a lot of other people in the same boat as them, that they could easily, like, just, I don't know, come together and put their minds to make something, at least, that they could showcase together. And so that's what I'm trying to maybe do here. So I don't know, what do you guys take on that? But that's kind of it for my yaps for this evening. I'm gonna go ahead and sign off here. We'll do some longer streams, like I did an 8 hour one on Sundays. On the weekends we do longer ones. It's just I don't have a lot of time on the 9 to 5 where my brain is super functioning, and yeah. So anyways, I appreciate you guys joining me this evening. Make sure to join the Discord and chat with me offline. People have been providing a lot of really great resources on there that I'm going to start adding onto the Discord, and I need to go through a lot of the messages I received and evaluate. It's been really busy. Today was my final day releasing my last level for my product, for my company, or not my company, but the company I work for, as a chemist. And so I released the final level, 360 something liters of this level, and gave it to them to start, filling up. And my job is done. I just got to do some paperwork tomorrow, and it's going to be an easy rest of the week for me. So I'll be able to focus on streaming and getting some good content out, and getting some more Python crash course videos and everything out for you guys. But we're going to be wrapping up this course very, very soon. Thanks so much for joining me this evening. You guys have a great one.